one guy who came to one of their shows, and they always remembered him as a hero. And they played a full set plus 2 encores for this guy.
Wow.
For this guy. That
You
is,
know,
sounds like
I mean,
a good
musicians,
idea.
they need their listening audience. They do.
Yeah.
You know, so
It's a great, if you like ZZ Top at all, or the blues.
oh yeah, I like them.
It's
A
a
lot of energy.
great
Cool.
documentary. Yeah, it's called the Little Old ZZ Top, that little old band from Texas, I think is
Right.
the name of it. Yep.
It's probably on Amazon Prime or something.
Yep. Or maybe it's
Netflix,
Netflix,
maybe?
I think. Yeah, yeah. Really good. Well done. As a film, even,
Yeah.
I think I gave a lecture once to no one in the audience.
Ooh.
I was once on a band tour and they only had 3 people in the audience.
Wendy was on a band tour and there were 3 people in the audience.
They never advertised it.
Because they forgot to advertise Wendy's performance. That's their loss, my friend.
My college band.
That's right.
Upstate New York.
Yeah. I remember Wendy and I visited SUNY at Cortland, where Wendy went to school.
Yeah.
We had lunch there with the president, who we really liked. And he asked Wendy if she was part of the large group of students that avoided their final exams
During Kent State.
that year after Kent State.
Mm.
And she said, "Oh, no, I was going to go into teaching, and I wasn't planning to avoid any exams."
I was young.
And the guy looked at her and said, "Well, why not?"
I said, I was young.
She said I was young and stupid, but she was not stupid.
Well,
Oh, here comes John Goss.
comes John.
Now we have a quartet.
That's right.
Hello, Dr. John.
Hi, John.
Hi, Dave. We've already been in contact today, so.
Yeah.
That smile you see on David's face is that Scotty and I have given him a happiness pill.
Yes.
Well, I needed one after today. Yeah.
I'll bet you did.
Oh yeah.
David, tell David next time be careful what he asks for.
Next time, be careful what you ask for.
I think if anything falls in on me, it would be nice if it were a meteorite rather than a plane.
I would think so, yeah.
You saw your own plane crash.
Apparently, he did not see it. You didn't actually witness it.
No, I didn't see it, but we all heard it, all the neighbors and myself as well. And then went out a little while later, and their place started to swarm with sheriffs.
Wow. So that was in your town that happened?
A plane crashed in our neighborhood, John, about 2 houses away across the street. A 2-seat experiment, maybe not. Well, I guess it is an experimental. One of those 2-seat kit-built planes.
Right.
Yeah, called what is it called? I'm not a plane expert, but it's if you want to look at, it's a Glass Air Glass Star. It was. So it looks like kind of a very small Cessna, two-third scale Cessna, 2 people who were kind of squeezed in. And unfortunately, they did not survive, the people on the plane, but it came very close to hitting a house near us. So it could have been much, much worse.
Jeez.
Yeah. Unbelievable.
Makes you appreciate what you have, as Wendy says.
Yeah.
Well, David, I have you on for a span of I copied the last time that you were on where you had like a 45-minute span. So I'll see if I can get some people to come on a little bit earlier, especially considering the circumstance. So
Scott, unfortunately, you know me, so you know I can talk as long as you want me to. But because you know me, you know that you don't want me to talk as long as I could talk. So
the endless droning of those who drone on endlessly. Yes. Barbara Harris is on.
Barbara,
Hello, Barbara.
Good evening. How's everybody?
Oh, we're fine today.
hanging in
We're all
there.
set for our global star party.
I was up all night, so I just woke up from my nap.
Oh, did you?
Ooh.
Yeah.
Gotten very quiet all of a sudden.
Yes. Right.
It's fatigue for me.
Yeah, I'll bet.
Yeah. Yeah. You got to feel a little beat up, I think.
Yeah.
Are you going to describe your events in your lecture tonight, David?
The events of the day today?
Yeah.
No, I don't think so. Not for the whole audience.
Yeah. Okay.
Yeah. It's too out there, I think, probably for that. But
Yeah.
this is something you can't say very often, but in case Barbara wonders what the hell I'm talking about, there was a plane that crashed in my neighborhood today, Barbara, believe it or not.
Really?
Yeah, yeah. And unfortunately, the two people on board are deceased, but it actually came in very close to a neighbor's house and sheared the top of a tree off. And so it could have gone straight into this house. And so at least that didn't happen, but a very,
Oh.
very unusual, strange day in the neighborhood here.
When you said that, I was thinking of there was one that happened yesterday
The
in San
in
Diego.
San Diego that I think went into a neighborhood there. Yeah. And
Yeah,
hit some
it
buildings.
hit the UPS truck first and
Oh.
then crashed into the house. So it
Oh.
killed the UPS driver, but the
Oh,
people in the house were able to get out.
gee. Oh, boy. Well, that was similar, it sounds like, but more deadly than today's here. Yeah. Ugh. Mm.
Well, that should leave you a little jumpy.
Well, life is a fragile thing. We need to, this is more evidence for the value of the global star parties, that we all need to get on here and share our enthusiasm for the community.
How far is it? Isn't she on the schedule? Like,
Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and welcome to the 68th Global Star Party. This is our special theme is strange universe. And once you start learning about the universe, you start to understand, as you peel back some of the layers of discovery and exploration and latest findings, you start to find out the universe becomes even more strange as we go along. But it is a fantastic journey for anybody to embark on. And so that is our topic. And we will discuss that in various ways because it can cover just about anything to do with astronomy, you know. Joining us, of course, tonight is David Levy, David Eicher. We have John Goss here and Barbara Harris. We have more people joining us later in the program. But I always want to say something special about David and David. They've been stalwart companions for most of the astronomical community for decades now, writing books, giving lectures, traveling the globe to share what they know about astronomy and to share their passion. When I look back on all of their accomplishments, I'm in awe. My jaw drops. And we're so lucky to have them with us tonight, and I look forward to all the other things that they'll do in the future. But anyways, we will start off with David Levy, who always gives us some nice words and some nice poetry. So, Mr. Levy, I'm going to turn it over to you.
Well, I thank you very much, Scott Roberts. It's really a pleasure to be here, and it's going to be a lot of fun to, excuse me, I'll try that one again. It's going to be a lot of fun to hear and see what everybody has to say tonight. And I noticed in the ad, you had Neil Tyson saying that the universe is under no obligation to make sense to you, and which kind of inspired the quotation that I would like to read right now, the first of two quotations. This one is by Stephen Crane, and he wrote this obviously between 1871 and 1900. A man said to the universe, "Sir, I exist. However, replied the universe. The fact has not created in me a sense of obligation. And I think that's a pretty important thing. Much as I appreciate the writings of the poet Stephen Crane and Neil, who I know very well, I disagree with it. I don't think that that's true at all. And what really said it was the night before the 2001 total eclipse of the sun in Africa. And the then editor of Sky and Telescope, Leif Robinson, was talking about a similar topic. And he said he did not agree with that at all. He said each of us is unique and precious. And of course, that reminded me of that famous Star Trek episode, Balance of Terror. And I think everyone here has seen that, when Dr. McCoy says that he's talking about the universe and everything that's in it. And in all that, and perhaps more, only one of each of us. He's making the very appropriate and salient point that each of us is unique. Which brings me to my second quotation. It's from Max Ehrmann. In 1927, he wrote a poem that is now called Desiderata. And I'd like to quote from that right now. Go placidly amidst the noise and haste, and remember what peace there may be in silence. Beyond a wholesome discipline, be gentle with yourself. You are a child of the universe, no less than the trees and the stars. You have a right to be here. And whether or not it is clear to you, no doubt the universe is unfolding as it should. Be cheerful, strive to be happy. And now back to you, Scotty.
Very nice. Very nice. That's great. Um, I'm always amazed at how you're able to find so many very appropriate quotes, poetry, for every moment of the star parties that you've attended in person and this series of global star parties that you've done. It won't be long before we're hitting 100 global star parties. But I can imagine that we'll never exhaust your ability to find just the right words to say. So thank you,
Well,
Dave.
they're all here in this book, Scott, and, every one of them. And so if someone comes in one night and steals this book, I'm going to have a problem.
We're
Here in this book.
We're in deep
This
doo-doo.
is my magic book. Yeah.
That's great. That's great. Okay, well, thank you. We will now go to John Goss at the Astronomical League. John, thanks for coming on tonight, and happy to, as always, to have the Astronomical League, attend the Global Star Party. And we are, it's really kind of an honor because, the League now this is the 75th year, has just added so much to the dimension of amateur astronomy. Yeah, I have my cowboy hat right over here. And I do sometimes wear it, guys, especially if it rains or whatever. But I got my 75th year pin right here on that side. And then on the other side, I have the virtual Astronomical League pin right there. And I'll add some more League pins to that hat. That'll be my astronomy hat, which is, it's great to use for covering things up and keeping the light out of your eyes and all of that. So, but not the starlight.
If you like pins, we've got pins.
You got pins. That's right. That's right. I think you wanted to say a few words before we got into the questions and answers. And
yeah, I think I have two topics. One, I think I'll dovetail in with one of the questions. You'll see what I'm talking about in a moment. But the other one, it's something I just like to bring up. I've been discussing this topic with some other Astronomical League members across the country, and the idea here, since we're coming towards the end of the year, and this tends to be more of a time for gift giving.
Mhm.
The idea is that if you have a small unused telescope, an unused but usable telescope, why not put it to good use by giving it away to somebody who could benefit from it?
Sure.
Um, be nice if clubs could have programs. You know, a club is the focal point of astronomy in the community. And you know, if you're in a club, people are going to donate stuff to you all the time that you really don't need. Um, Small telescopes, I will say beginner telescopes,
Mhm.
but you know, your club members aren't going to use them. And so you have this pile of equipment. What to do with it? Well, why not fix them up and give them away to a young person who will likely not receive a telescope on his or her own? Perhaps donate it to a community service organization, to your county or parish benefit society, United Way. I don't know. Find some organization that
Sure.
does stuff, and you can fix it up and give it away to a deserving young person. I don't know. That might be the spark.
It's a good idea. Years ago, you might remember Mike Reynolds, Dr. Mike Reynolds,
Oh yes.
and Mead Instruments had 8 containers of small telescopes that were going to be they were just going to be destroyed, you know? And for me, when I see a telescope, if I see a telescope that's made, and I know the effort that it takes to make a telescope, and if it never sees starlight, you know, if it never gets to see starlight, I think that, you know, I feel like it's lost its purpose, you know, and it's a little sad to me to see a telescope go from department store
Exactly.
to being returned and then just tossed, okay?
Yeah.
Because the smallest telescope can still work. The
Oh
smallest
yeah.
toy telescope works better than Galileo's telescope did, and he changed the world with his, okay? So, you know, you know, so I've always kind of felt strongly that a telescope should at least get to see stars at least once, you know? And so astronomy clubs can do that. And the Northeast Florida Astronomical Society took 8 containers of telescopes,
Oh, great.
was, as I recall, a couple of thousand telescopes, something like that. And with the Boy Scouts, distributed these telescopes, and they trained everybody how to use them. That's quite one thing just to give a telescope to somebody, here, have fun, you know. It's quite another to be actually trained how to use it, you know, because it's that training that can really send somebody off a long way, you know. It's with that training that they might join the Astronomical League or join up with your club, or to subscribe to Astronomy Magazine, you know, and they start this lifelong voyage of exploration that can start with a very humble instrument, you know. I often show my little Kmart telescope that I was given when I was 10 years old, but, you know, wow, what a ride it's been, you know. So
As you said, that the smallest telescope, they can take you on a journey to the moon and back.
that's right.
You know, or you know, some of the brighter planets. I think part of the trick is if you have a used telescope, is determining how usable it really is, to make sure it's in good working order, has a couple of decent eyepieces, and always keeping in mind who this is for. You know, this isn't for you who've been out under the stars with huge Dobsonians. This is for a newcomer, a kid who just wants to see the moon and get started, you know, and
it needs a spark, right? And needs a little bit of gear.
Last year, a couple of years ago, your friends at Celestron sent me a telescope, and they sent me the wrong telescope. And so I told them about that, and they said, "Well, go ahead and keep it and give it away." And I was thinking, well, you know, I don't want a telescope. It was about a 3-inch telescope, 3.5-inch reflector, and I thought, you know, I'm certainly never going to use it. None of our club members are going to use it. So we gave it away last year to the county Department of Human Services, and boy, they were really too. they were really happy to get it. And they knew of at least one person who would appreciate receiving that as a gift come the holidays. I won't say which holiday, with the holiday season. So anyway, I guess I'm
work.
just bringing this up. We wanted to put this in the back of their minds, and maybe something can get started with this.
That's right. That's right. That's how it all starts. So
Yeah.
well, that's great. Thank you,
Okay,
John.
well, let's move on to some questions here. I gotta start it up. Helps. Then we'll do that. Okay. I hope we all can see this. The Astronomical League has been on the star parties, and we've offered 3 questions each time, but 3 kind of trivia questions about something to do with astronomy. Before we do that, we always like cautioning people about when they do observe the sun. These questions tonight aren't about observing the sun, but if you get that hankering to go out and do so, you should do so in a safe manner. And it isn't really hard to do if you have the right equipment. You want to make sure you have the right solar filters that fit on the front end of the telescope and not over the eyepiece. You want to make sure that if you have a finder scope, that it is blocked off so you don't accidentally shine it on the sun, illuminating a strong beam of light down to who's ever standing in front of it. But anyway, if you follow these rules, things will go well for you with a telescope. So let's get on to question number 1, I think. Answers from last week. There were 3 questions asked last week, and we will answer them now. We'll also give another 3 questions this week. Last week in the Global Star Party, it was Carol Orge, our organization's president, who gave these questions. What is the name of the new Astronomical League Imaging Award for women sponsored by Explore Scientific of all people? Thank you, Scott, for doing so. Now, obviously, the answer there is the Williamina Fleming Imaging Award. This is kind of a good thing to bring up because I understand, Scott, that Molly Wakeling is going to be on later on tonight.
Yes, actually, she will.
Okay, well, she's the very first winner of that from this past year. So
Right.
you can tease her about it.
Sure.
But,
Sure.
we're continuing it on this coming year, and thank you, Explore Scientific, for helping us make this possible.
Thank you.
Question number 2, right out of Shakespeare. I thought David Levy would really like this question, right out of Shakespeare. Ariel, Umbriel, Miranda, Titania, and Oberon are all moons of which planet? Well, the planet Uranus. And I think these moons are also in a Pink Floyd song, but I can't remember the name of it. I won't go there. Question number 3. What unit of length is equal to about 3.26 light years? Now, to astronomers, we all know this. It's parsec. But to newcomers to the hobby or to science fiction, thanks to, I think it was Battlestar Galactica, parsec was tossed around every episode, and it was wrong. Parsec is not I think it was a unit of time in the show. But no, it's a unit of distance. So those are our 3 questions. The winners, we had what we do is we select the correct answers that people submit and put their names in a hat, so to speak, and they will be drawn in a few weeks for a door prize. So last week was Norm Hughes, Josh Kovac, Andrew Corkill, Israel Monteroso, and Cameron Gillis. So thank you for entering. We'll move on to this week. Questions for this week. If you know the answer, send it to the secretary at astroleague.org. They will not be announced tonight, obviously, but they will be done next Star Party, which I guess will be next Tuesday night. So please send it to secretary at astroleague.org. Question number 1, which I think we're going to ask, and then I might say a few more words about it. Yes, this is question number 1.
Okay.
The famous nebula immediately, we aren't going to say anything about it right now. All right, I'm sorry. The famous nebula immediately east of Deneb is known as A, the North America Nebula, B, the Great Nebula of Deneb, C, Hubble's Nebula. So if you know the answer to that, send it to secretary at astroleague.org. Question number two.
Number
Excuse
two.
me. Question number two. And what caused the sun lie in front of tonight or today? Okay, let me read that off again. I just had to note that my internet was unstable there. In what constellation does the sun lie in front of tonight? If you know the answer, secretary@astroleague.org, please. Question number three. Which major planet is closest to Earth tonight? Which is farthest? Remember, they all won't be lined in a row and they all won't be on the same side of the sun. Is the closest Venus, farthest Neptune? Or B, is the closest Venus, farthest Uranus? Or C, the closest Mercury and the farthest Neptune? Secretary@astroleague.org if you know the answers to that. One more, those are the three questions. I have one more slide, kind of a plug for this coming Friday night. The Astronomical League is presenting its live Zoom meeting, courtesy to help with Scott Roberts again. We will be having I guess a holiday theme type meeting, some interesting stuff, kind of the spooky and strange.
Yeah.
Well, Terry Mann, our secretary, is going to be talking about Aurora, Soul of the Night. Rumor has it that I'll be on it talking about the moon. David Levy will be on it, Celestial Incantations, which I'm sorry, David, I made up that name. I hope that was okay.
I'll be on there too.
Barbara Harris will be talking about Algol, the demon star, and Molly Wakeling, who we were just talking about a few minutes ago, Spooky Nebula of the Night. And our two more people, Mary Stewart Adams will be talking about passing between the worlds under October skies. That I'm interested in seeing, because I'm not quite sure what she means by that. And Astro Bob, who's always a very interesting speaker and always has a lot of great topics, I guess is talking about everybody's favorite topic, black holes, where matter goes to die. You can never lose talking about black holes. Your audience will always stay with you. So that's great. But anyway, this will be this Friday night. What they call it, same bat time, same bat channel type thing. So we hope to see you all then. That's pretty much what I have, unless we have some questions, and then I can try to think of some goofy answers.
There was just some questions about where to go find a used telescope like that, and I recommended an astronomy club, but where else do you think? And Cloudy Nights was also recommended, but where would you start? If we're looking to get a used telescope.
Well, remember what I was just saying. It's not just a used telescope. It has to be a usable one.
Right.
And really usable means something that can't be too frustrating to use. So you want to have something that actually works. So you look at places like secondhand stores or Goodwill. Sometimes those have them, but sometimes they're also missing components.
They're missing parts. That's true. And at
the old finder scope,
or it's so worn out that the mount is too wobbly to make it usable, and these kinds of things. If you're handy, you can, of course, fix these things. And
you ask where to find these. As you said, I think the best place would be an astronomy club. Over the years, people donate stuff to clubs, and clubs are like everybody else. They don't want to throw this stuff out. So it's in somebody's house right now in their basement, and they probably have several of these things.
Right.
And it never comes up because amateurs who are really into the hobby, they're not interested in this at all. But these scopes still work.
They still work. That's right. You can still see the rings of Saturn. You can still, with a small refractor. I took one to the Texas Star Party one time. I took a 70 millimeter department store level type of refractor. And, Texas Star Party is really dark. And I was able to find the Whirlpool Galaxy with it. And I called people over that were using big dobs to come and look through the eyepiece. I threw an inch and a quarter eyepiece on it. You put a decent eyepiece on some of these small telescopes and they provide decent views, and so you could just make out hints of the spiral arms of the whirlpool galaxy with it, so there's a number of things that you can see with it. Occasionally I see in the magazines challenges like trying to find the Herschel 400 with a very modest telescope, and it can be done. So, and I'm talking about a 70 or 80 millimeter refractor or reflector type of telescope. That 3.5-inch reflector that you got from Celestron, could see a number of
yes,
a sizable number of deep sky objects. So,
well, I'll tell you something that's top secret. So don't tell anybody this.
Okay.
But
we're only broadcasting.
Yeah. So just keep it down. Keep it down.
Just keep it under your hat.
You've probably all heard of a program called the Library Telescope Loaner Program.
Yes, that's right. That's a great program.
Well, here's the top secret thing. Sometimes things wear out on these telescopes, so they don't work quite properly. But the Library Telescope Program group of people have managed to figure out how to 3D print a number of parts for these telescopes.
Components. I see.
So, once you figure out how to print it, something that costs, $20-$30 to buy, costs you $1.50.
Right.
So you may hear more about this initiative. Remember, it's top secret, so don't tell anybody else. But you may be hearing more about this as time goes on.
Very cool. Very cool. Awesome.
That's what I have for tonight.
John, thank you so much. Thanks for coming on, and thanks to the Astronomical League. It's great. Okay. All right. So up next is the one and only David Eicher. And David is going to, he has shown us his treasure of minerals and gems, but he has so much of it that it's been a nice series. The specimens that he shows are amazing and beautiful, and of course, they're all made here in our home, the universe. So, it's some of the specimens I saw in the last programming that he did were just stunning, and I can't wait to see what he has tonight.
They're custom made to order, Scott, right here on Earth, on our own planet.
Right.
Nowhere else. Yep. We're not talking meteorites here. And so this is the next chapter in exploring how the universe makes planets. And this is not an accident. I'm going to try to switch into screen sharing here. This is not an accident. This is the chemistry of the universe showing us that, what am I trying to do here? Sorry, it's been a long day. This is the chemistry of the universe telling us that chemistry is systematic and consistent throughout the cosmos. We know that through spectroscopy, of course, and we know that it's no accident how planets assemble atoms logically and in a precise order. And before they get all mixed up in a blender and become rocks and other things like that, they're assembled in order because the atoms in them are electrochemically attracted in the kinds of very hot fluids that get going as minerals form on Earth. So we have about 5,000 mineral species on Earth. Scott, I don't want to gravely disappoint you. We've only gotten through about 40 so far.
Okay.
So there's a little ways to go. But I thought this is a tanzanite crystal here that's a very beautiful gemmy stone, mostly from Tanzania, thus the name. That's a kind of zoisite. And these silicates are very, very dense. They're very hard minerals because of the silicon atoms in them. So they're very popular for jewelry. And tonight I thought we would look at another popular group of hard silicates that are colored by different impurities. and they have different constitutions, but they're all similar and have these sort of substitutions of a few elements that go in and make them a little bit different. And that is the garnet group. This is not a mineral, but is a group of minerals. And they're very popular for jewelry as well, because they make nice little gemmy crystals in cubic and isometric and tetrahedral and other kinds of crystal shapes that can be cut very nicely, and they wear very well, and they have strong color and all that kind of thing. The color in these gems comes from impurities of a few iron atoms, or in the case of the strong green ones, chromium, or a few other contaminants that get in there and color them and make them really nice and pretty. So I thought we'd do a very basic introduction to the garnet group, which is a whole group of minerals. And there's 6 major types. These are not all the varieties, if you will. It's kind of like talking about galaxies, but these are the major types of them. And you can see that they have some sort of substitutions of some of the elements in here in the same basic chemical formula here. Almandine, that's an iron aluminum silicate. Andradite, a calcium iron silicate. Grossular, calcium aluminum silicate. Pyrope, which is magnesium aluminum silicate. Spessartine, a manganese aluminum silicate. And uvarovite, which is a very strong green, emerald green colored calcium chromium silicate with those chromium atoms in there. And you can see the chemical formulae there, and it's too late at night to get into the whole basis. Another time when you're really hard up for material, Scott, we'll talk about chemical formulae and how they're derived and what that means.
Sure.
We don't want to get into that tonight. It's too late.
Yeah, we'll have to make all the connections, though.
Yeah,
Eventually.
Absolutely. Maybe a little earlier in the daytime. But here is the sort of a basic, simple, if you can believe it or not, diagram showing you the basic crystal structure of a garnet group mineral. This is a grossular, and you can see that there are numbers of oxygen and silicon and aluminum and iron atoms that all go into this crystal lattice. And the hot fluids that flow through these sort of pegmatite rocks and make these kinds of minerals cool down, and they crystallize over long periods. And the arrangement of these atoms is the same. And so that is one crystal lattice. And then the more fluid there is, the more of these lattices can build, and you get larger and larger crystals. So that's how the world likes to make minerals. So without further ado, we can look at a few examples of these. These are from my collection. You can collect minerals too, which is a very handy form of planetary geology, one of the areas of our love and our interest of astronomy, because this is what planets are made of. And because we know the chemistry of the universe is uniform everywhere we look because of spectroscopy, that wonderful invention, we can imagine that although temperatures and pressures and other local conditions would be drastically different from planet to planet to planet throughout the Milky Way galaxy and other galaxies, all the other 100 billion galaxies that are out there, the basic chemistry would be pretty similar on a lot of planets. And so there might be minerals that are quite similar to many of these 5,000 that we have on Earth. So without further ado, we can look at just a few examples of these natural minerals that don't look quite like the garnet rings you might buy, but this is the natural stuff in matrix, as it were, or in country rock, as mineralogists like to say. That is, these are garnet crystals that, as they are really dug out of mines here and there. So this is grossular. It's nicknamed raspberry grossular. You can see that from the color here, and it is colored in part a little bit by magnesium and a little bit of iron impurity in here as well. And this is from a very well-known mineral locality in Coahuila, Mexico. So this is where some of the very nice raspberry grossular garnets come from. This is a specimen that's about as, and we are kind of handicapped with these because to show you the really nice images here, we're not showing the rocks live, as it were, but this is about a sort of a little larger than a softball size, fairly good size
Big.
specimen here. And so those are pretty good sized crystals. Well, this is somewhat smaller, and these are tiny, tiny crystals, and this is that chromium-rich kind of garnet. This is from Russia, a very well-known locality there. There tend to be, sometimes with minerals, important places where some of the best specimens come from, although they can come from many, many localities on Earth. Some of the better specimens come from a handful of places on Earth, and mineral collectors and mineralogists are obsessed, as we are with the NGC and the Messier catalog and other things like that. They're obsessed with localities of where minerals come from, not only a region and a state and a district and a mine, but sometimes even down to the specific shaft or stope or horizontal adit within a specific mine, even, of where these things come from. So they're really obsessed with locality because that defines the quality and the origin of the specimen. So this is that chromium-rich, really emerald grass green uvarovite, which is an unusual kind of garnet. This is a kind of, you can see this is a huge crystal. This is about a 6-inch piece of schist here, it's called, the rock. And so you can see this is maybe about a 3-inch diameter big crystal here. This is called almandine. And these big, dark red, sort of bronze fire red almandine crystals come from the Alps. This is from the Tyrol region of Austria, high up in the mountains there, and they form there. And so this is that almandine, which is colored chiefly by iron atoms. Well, this is back to some grossular from Mexico again, but showing you, see if I can go back, from one specimen to another from the very same mine. You can get some tremendous variation in color and in what mineralogists call the crystal habit, the way the crystals form, the structure of the crystals. Very, very different, even though this is from the same mine. This one and that one, this sort of bubblegum pink one here. So that shows you the same mineral, the same species, the same mine, but a good variation. So it gives you a huge variety of if you get addicted on collecting this stuff, it's as bad as collecting galaxies at the eyepiece.
Yes.
This is one back in Europe. This is from Lombardy, Italy, and this is a very famous locality as well. And it's a kind of andradite that's called demantoid, and this kind of pearly olive green color of these sort of rounded crystals. Very popular and a very good specimen of that. Showing you kind of the variety of, these are all very closely related in the same family of minerals here, the garnets. This is andradite. This is with an iron-rich sort of silvery-looking mineral there called hausmannite as well. But this is andradite, the rich red garnets. It comes from South Africa. And this is a Greek specimen now of andradite, and you can see very, very different looking crystals here between. This is the same mineral, same chemical composition, different color because of the impurities here. But they're both in part colored by iron. And you can see the larger crystals here of this Greek specimen. The chemistry changed as these crystals were crystallizing, were forming. And that gave the crystals this kind of dark boundary around the edges of the crystals there, which is very unusual, which mineralogists call zoning. This is back to a chromium colored mineral. This is a grossular garnet from the Jeffrey mine, a very famous mine in Quebec. Canada, and it's colored again by chromium atoms that are the impurity here and give it a very, very strong green color. This is a very common kind of garnet called spessartine. It's cut a lot for jewelry, and this is a Chinese specimen. There are huge numbers of spessartine that have come out of Chinese mines and are on this whitish matrix and are cut and used for jewelry. And you can see that kind of classic shape that can be cut into stones there. This is back to that same mine in Quebec as we saw a moment ago, but this is a grossular that is colored by iron and other impurities that give us this sort of honey orange color from this specimen.
Beautiful.
And I'm sorry, Scott.
I said it's beautiful.
Yeah, you know, there's a tremendous amount of variety in making a planet, and we don't normally see it because we see, you know, the ground up, you know, soil on top of our world typically, but there's all sorts of adventure if you dig down and find some things that are a little more unusual. And then I thought I would finish with, this is a sort of a big crystal here. This is from Tanzania, and it's called a spessartine and is colored orange by iron chiefly. And this is about a 2-inch single crystal, so a very large crystal that could be cut and made into jewelry, which again shows you the kind of, you can see the crystal faces on this piece. And again, I will close with the shamefully commercial mention of books and Astronomy Magazine once again.
Hear, hear.
But,
Good.
Which occasionally talk about how stars form and minerals and all that kind of nonsense. And that's all I have today, Scott, is another little chapter in how we make planets.
It was great. It was great. I'm curious about something. You know, of course, we found all these minerals and gems and all their variations and stuff here on Earth. Do you think that we'll find those eventually if we mine, you know, create mines in Mars? Or
there's no question. Now, Mars is very mineralogically rich as well, and you can see the most abundant mineral on Mars, even looking through a low-power telescope, because its orange color gives away its famous mineral iron oxide, aka rust. But that's partly a joke, but not really. But Mars has a lot of minerals. Now, it doesn't have the free oxygen in its atmosphere that we do. There is oxygen, there is water on Mars. It's locked up mostly now in subsurface aquifers, but Mars probably has about, you know, 50% or so, or maybe 40% of the mineral species that we have on Earth.
oh wow,
Earth 2 point some billion years ago, I think it's 2.3, but I may be wrong there, underwent a critical moment in our planet's history, and that was the Great Oxygenation Event, the GOE. That was when the very simple organisms, cyanobacteria and other very simple organisms, suddenly, not suddenly, but over time, produced enough oxygen such that there became a lot of free oxygen in Earth's atmosphere. And oxygen likes to what? Chemistry students, react with things. It's extremely reactive. So when we had a lot of free oxygen after a couple billion years, or 1.5 billion years of microbes on our planet, we exploded the number of mineral species, tripled them from about 1,500 to near 5,000, because oxygen combined with all these minerals in new and different ways. And it made life explode as well, and the eventual emergence of human beings. So the Great Oxygenation Event, if you can't sleep tonight and want to look up something on Wikipedia, was a critically important moment in our planet's history for life, for what led to us, courtesy of the dinosaurs disappearing, thanks to that asteroid, and the explosion of mineral species on Earth, all due to that Great Oxygenation Event.
wow.
A couple billion and change years ago. Now, to answer your question, So Mars has a fraction, and it's a fairly good fraction of the minerals that we have, but not nearly as many as we do. And a body that has almost no free oxygen, the moon, for example, has maybe about 1,000 or less mineral species. So many, many planets out there in the universe have a small number of minerals compared to an oxygen-rich world like ours.
Very interesting. Very interesting. Great. Wonderful. Well, David, thank you very much. And you have a good night and get some good rest.
Thank you, Scott. Will do. Take
Thanks.
care, pal.
Thank you. Okay. Well, up next is Barbara Harris. Barbara is someone that I've known for at least 20 years. I met her initially through Don Parker and Tippy Dioria, that were people that were always at the Winter Star Party. But so I think Barbara Harris is probably also one of these people that was at almost every Winter Star Party. And this is a very famous star party down the Florida Keys. If you haven't been, you got to go next year. I'll be there broadcasting the event live. So it should be a really cool experience. But Barbara is also a discoverer of at least one supernova. She is very involved with the American Association of Variable Star Observers. She has a beautiful observatory down in near her home, and she's an avid astronomer and has contributed a lot to both the amateur astronomy world, but also to variable star research. So, Barbara, thank you very much for coming on the program.
You're welcome, Scott. Glad to be here.
Yeah.
Okay. Okay, I'm trying to do this with my iPad.
We'll hang in there with you, Barbara. No problem.
Yeah, I'm usually on the desktop, but I'm gonna try my iPad tonight. Okay, is my slide showing?
Not yet.
Okay. Then I'm not sure how to.
There's your camera back.
Okay. Get to share content. Okay.
I know it can be done.
Nope. That's not what I want. Bear with me, please.
No problem, Barb. Don't worry.
I may have to get to another computer.
That's fine. I could probably have switch you up with someone else if it's going to take a few minutes. Let them.
Okay.
Earlier today, I ran
And
into something very similar where my whole sound system went offline, so I had to fix it. There we go.
so do you see my slides?
I don't see your slides, but I see something that says screen broadcast. Oh, now I do. Now I do. Strange stars.
And-
There we go. You did it.
Okay. Now, sorry.
No problem.
Okay. So tonight I'm going to talk about some strange stars in our galaxy and in our universe. So I'm going to choose 5 particular stars that are kind of bizarre. The first one is our Corona Borealis, and it's a star that's described as a reverse nova. I'm also going to talk about 3C 273, which is a star that is not a star. Also going to talk about Epsilon Auriga. It's strange behavior from one of the kids. And also Tabby star. It's the WTF star. And I'll tell you what that means. And lastly, I'll talk about Barnard star, the fastest star in the galaxy. So many astronomers look at stars as just a way to guide them to a deep sky target. Most amateur astronomers, they're only interested in what's between the stars and using the stars as guideposts to get there. But each star is unique in itself, and they all have a tale to tell. And some of those tales are very strange that we'll discover with these few that I'm going to describe. So the first star I'm going to talk about is our Corona Borealis, or as the variable star observers call it, our Core Bor. It's in the constellation of Corona Borealis, which is the northern crown. And this time of evening, like just right after sunset, it's low in the western sky. It's mostly a spring constellation, but it's tucked between the keystone of Hercules and the constellation Boötes. And it is shaped like a horseshoe, and just east of center of the middle of the horseshoe is our core Bor. Now, it is a variable star. It's one of my favorites that I've been following for several years. Its magnitude ranges anywhere from 5.71 to 15.2 mag. And it's the prototype star of the variable star group, R Core Bor stars. And these stars, they start out bright, and then at irregular intervals, they'll start to fade. And this fading is unpredictable as to when it's going to occur. And it's also unpredictable as to how long it's going to last. It can last anywhere from weeks, months, or years. And our Core Bor itself is a yellow supergiant that's about 100,000 times as bright as the sun. And the reason it's described as a bright nova is because a nova usually starts out very, very faint and then becomes very bright, and then it will gradually become dim again. But this star's baseline is very bright, and then it will fall at irregular intervals. And basically recover and just stay. Like right now, the last observation yesterday was about 6.1 mag. So it's still up here. We don't know when it's going to dim again, and that's why it's important to follow it and try to figure out what's happening when it's dimming and if anything new is occurring in the star. So this is an artist rendition of our core bore. And this artist rendition is based on observations of the star from the European Southern Observatory using the Very Large Telescope in Chile. The dimming of the star is thought to result from large clouds of dust that are spewed from the star. It is composed of 90% helium and less than 1% hydrogen, and the remainder is carbon. And this is unusual since the majority of the stars are mostly hydrogen. So this star contains very little hydrogen, mostly helium and carbon. And it starts to actually spew carbon soot from the star. And that soot envelops the star and creates dust around the star. And that dust is what is causing the dimming of the star. And it's unknown how long it takes the dimming to clear up. But once it clears up, then we can have our bright star again. So the amount of dimming is basically how much dust is around the star and how long it takes to clear up. 3C273 is the next star I'd like to talk about. It's actually a quasar or quasi-stellar object. It's in the constellation of Virgo. It's a variable star that varies between 12.2 and 13.57 magnitude. And it's another one of my regular variable stars. The image that you see identifying 3C273 is one of my images from earlier this year in March 18th, and I measured it at 13.08 magnitude. Now, what's unusual about this compared to other stars that we see is this star, which is actually not a star, and we'll get into a little bit later, but it's actually 2.4 billion light years away. And it's probably the furthest thing that we as amateur astronomers are going to be able to visualize with our telescopes. But this is actually not a star. It's an active galactic nucleus, meaning that it's a galaxy with an active nucleus. And this nucleus is most likely a massive black hole. And the name designation 3C273 means that it's the 273rd object in the third edition of the Cambridge Catalog of Radio Sources. So this quasar is actually has a very strong radio source. This is a Hubble image of 3C273 taken, I think, around 2013. And what's unusual is at about the 10 o'clock position in the image, this streak here, if you can see my cursor, this is a jet that actually protrudes from 3C273. And this jet actually extends 200,000 light years away from the center of this quasar, this active galactic nucleus. So it's a pretty bizarre item in the sky. And besides being a strong radio source, this is also a very bright X-ray source. Okay, the next object that we're going to talk about is the star Epsilon Aurigae. It's one of the three kids in the constellation Auriga. So most of us know about Capella and the kids. So here's Capella, and here's the three kids. This particular one is Epsilon Auriga. It's a variable star also, and it usually varies from 2.92 to 3.83 magnitude. It's 2,000 light years away from us, and it's an eclipsing binary star. It's one of my favorite classes of variable stars. Eclipsing binary stars are two stars that rotate around each other so that one star eclipses another. Now, this particular eclipsing binary has a period of 27.08 years. It's one of the longest known periods in eclipsing binary stars that we know of. The last eclipse of Epsilon Auriga happened in 2009, and the eclipses usually last 3 years. So it was between 2009 and 2011 that we had the last eclipse, and the next eclipse is going to be in 2036. Now, this is an AAVSO light curve of the last eclipse of Epsilon Aurigae. This is, I think, probably about a 4-year span of Epsilon Aurigae. So the baseline is close to 3 magnitude, and then the eclipse starts around here. So it dims, and then it stays dim for almost 3 years, and then it starts to brighten again until it comes back to baseline. And so the next eclipse isn't until 2036, but we still monitor it on a regular basis in case we find something else bizarre happening to it. This other picture is an interesting picture. It's taken by the Michigan Infrared Combiner, and that instrument is an interferometer that is housed on Mount Wilson. It's a collection of 6 telescopes, and they combine the light from those 6 telescopes to actually get an image of the star. So what we're actually seeing is an image of Epsilon Aurigae. And what's unusual about this eclipsing binary is that what's eclipsing the star is not another star, but it's this disk, this dark disk that's actually eclipsing the star. So it's one of the most bizarre eclipsing objects that we know of, and it has been a mystery for years, trying to figure out what's eclipsing it, because we've known for years that it wasn't a typical eclipsing binary system, that something strange was eclipsing the stars, but we couldn't figure out what it was. But it looks, we think it's this disk type object. We still aren't really sure what this disk type object is, but we know that it's a disk type object that's causing the eclipse every 27 years. Now, the next star I'd like to talk about is Tabby star, and it's labeled the WTF star. And Tabby is a real person. Tabby Boyajian is a professor. I think she's at LSU, but she discovered this star that was undergoing really strange behavior. The star is actually what's called a Kepler input catalog star. Its official name is KIC 8462852. And the Kepler stars were discovered by the Kepler Space Telescope. And if you don't know, the Kepler Space Telescope was launched in 2009, and it was launched specifically to hunt for Earth-like exoplanets. And it basically only looked at a certain area of sky. It looked at a 115 square degree area of sky between Cygnus and Lyra. So it concentrated on that area of sky only, and it looked for stars that it thought may have transiting Earth-like exoplanets. It would take images of the stars in that region on a regular basis, and they had a computer algorithm that would analyze the photometry and the data that came out looking for exoplanets. At the same time, they had a group of citizen scientists in what was called the planet hunters, and they would visually look at these light curves from the stars in this area, and they found this star, KIC 8462852. They found that it was dimming, but it wasn't dimming in a pattern that they knew there was not an exoplanet causing the dimming. So they started to investigate this, and the paper that came out of this was called "Where's the Flux?" And that's what the WTF stands for.
Okay.
They wanted to know where the flux that was coming from these dimming episodes, and there were several theories as to what was causing this unusual, unpredictable dimming of this star, but it was really difficult to find what it was. Some of the theories trying to figure out what was going on. One theory was that there were several comets surrounding the star, and depending on the angle we were looking at it, and what the comets were doing at the time around the planet, around the star, was one theory as what was causing the dimming. One theory was saying that there was a ringed planet and asteroid clusters orbiting the star. One theory was that a planet was basically swallowed by a star. And one of the most bizarre is that there was an alien megastructure around the star.
Oh,
And the press had a field day with that one.
yeah.
That's one of the reasons Tabby Star became so popular, is because someone proposed that if there was an alien mega structure around the star, that it would explain the brightness, the dimming, and so that was that one kind of took off with the press. Anyway, one of the leading theories so far is that Tabby Star is basically being dimmed by dust surrounding the star. Not sure where the dust is coming from, but that's one of the leading theories as to what's causing the dimming. And we're still monitoring this star. It's one of my favorites. And in fact, if I have almost 80,000 observations in the AAVSO database, and I probably have about 16,000 that are of Tabby Star. And as we speak, my observatory is open and imaging this star right now. So I image it every chance that I get. So it's a very interesting star, and I'm glad that I'm contributing to trying to figure out what's going on with it.
Sure.
Now, the last star I'd like to talk about is Barnard's star. A lot of amateur astronomers know Barnard's star. It's actually a red dwarf star that's 6 light years away in the constellation of Ophiuchus. And at 6 light years, it's actually one of the closest stars to us. It's only second to the Alpha Centauri group as far as nearness to Earth. It's also a variable star. Its variable star designation is 2500 Ophiuchi. Its magnitude is around 9.55 and only varies by about a quarter of a magnitude. And we do know that some of that variability is due to flaring of the star. But it also might be an exoplanet around the star. There was an exoplanet discovered using the it was discovered in 2018, but recent data this year calls that exoplanet discovery into question. So we're still not sure whether Barnard's star has a planet around it. But one of the most significant things about Barnard's star is not only is it very close to us, but Barnard's star has a very high proper motion, meaning that it moves very fast. And most stars that we can see have some proper motion to it, that they're moving either away or towards us or in some direction. They're not just sitting still. It's just that the stars are so far away and the movement is so slow that we cannot see the movement in our lifetime, that when we're looking at the stars, 10 years from now, 20 years from now, almost 100 years from now, they're all going to look the same to us. But Barnard's star has a very high proper motion where you could literally see movement every year from the star. And one of the projects that I've been doing with this star is I take a measurement, take an image every year, and I stack those images on top of each other, and it demonstrates how the star is moving every year. So
Wow.
this is where it started in 2014, and then this is where it ends up in 2021, and every little dot in between is the years between 2014 and 2021. So in our lifetime, we can see that this particular star is moving, and it travels about 10.3 arc seconds a year. So that's one of the claims to fame of Barnard's star. And then now also it may house a exoplanet around it too. So I'm not going to finish without plugging my favorite organization, which is AAVSO. All of the stars I've mentioned are variable stars, and more information can be obtained about these stars and other stars from the AAVSO. All these stars can be observed naked eye with binoculars or a modest-sized telescope. Additional observations of these stars will help to solve the mystery associated with them. Like something like Epsilon Auriga, when we had the big eclipse back in 2009, they encouraged people to observe it either naked eye or by using a DSLR. And we recruited a lot of citizen scientists to observe this either naked eye or with a DSLR. So a lot of that data that was collected during the eclipse came from citizen scientists. These are some of the books that I use for data about these stars, and they're some of my favorite books because I love stars, and I love these books. The one by Patrick Moore called "Astronomer Stars," it basically has a chapter on unusual stars like the ones that I've shared with you. So every chapter is a different star, telling you how unusual it is. The next book, The 100 Greatest Stars, is also similar to that book also. It basically looks at 100 stars and it tells you why it's a great star and what's unusual about it. And this book and the next two are by James Kaler. James Kaler is a professor emeritus at Illinois University, and he's most likely the godfather of stars. Like anything you want to know about stars, he knows about stars. One of his other books is Stars and Their Spectra, and then this other book, Extreme Stars at the Edge of Creation. These are all excellent books about stars. And at the bottom here, I have his website, where he basically, it's a website of almost any star that you want to know about. He has basically like a little biography of the star. So he's the godfather of stars, and it's interesting to look at his website and also read his books. Okay.
Wonderful. So Barbara, there was one question that also came to my mind too, is we had learned about, I think it's pronounced Betelgeuse, or Betelgeuse, or, Betelgeuse, or I've heard it pronounced many different ways, but, the red star, red giant star in near
And
Orion.
Orion.
Right. And it dimmed so much, it was startling how much it dimmed, and we were all, it was just something you could obviously, that you could obviously see. And we were, wondering, is it about to explode? Is it, there were a lot of things that were coming out about it. But I guess one of the determinations was that dust had spewed out from the star and it was obscuring it.
Yeah, that was the conclusion. And that one also the press had a field day with, because we know that one day, in astronomical terms, it's relatively soon, that one day Betelgeuse is going to explode and become a supernova. So when it started to dim, people started to wonder if it's on its way to becoming a supernova.
Right.
And the press latched onto that, and it's like, okay, is it ready to go?
Any
boom?
second now, it's going to blow,
yeah,
right?
and it was determined that it's not quite ready yet, and it looks like the evidence shows that it spewed out a lot of dust, basically kind of like Arcor Bohr, and that dust accumulated around the star. And then as it started to dissipate, Betelgeuse started to brighten again. And even before that, Betelgeuse was known to be a variable star, and it would dim, but this was the most significant dimming that we have seen since monitoring Betelgeuse. And if you want to know more about that recent dimming, AAVSO does weekly webinars, usually on Saturdays. And this past Saturday, a professional astronomer gave a webinar basically on Betelgeuse and what happened during that dimming period. So it happened live last Saturday, but you can go to the AAVSO YouTube channel and you could view the presentation for those who want to learn more about Betelgeuse. It was actually a very interesting presentation. So it's up on AAVSO's web Yahoo channel,
I see. Which I'm
YouTube
sure
channel.
there's links to it from its main website, which I just
Right.
put up there. The organization you mentioned is 110 years old. So this is, there's a wealth of information about stars. It is an organization that absolutely will take you under their wing and show you the ropes on how to make scientific measurements of stars, and basically prepare you for a life of science. So which the next steps in that is to do some pro-am.
Yeah,
activity.
and even though many of us amateurs have cameras, many of the observations in the AAVSO are visual observations, either naked eye with binoculars or through a telescope. There are people with 100,000 or more visual observations of stars, and visual observations are still actually, I think a few years ago, CCD digital observations just surpassed visual observations. But until a few years ago, most of the observations, most of the data was visual observations. And especially bright targets like Betelgeuse. Betelgeuse is actually hard to do photometry with the camera because it's so bright, it saturates so quickly. In fact, that's how they discovered that it was dimming unusually, is the visual observations that were done in the AAVSO database. Professional astronomers routinely look at and monitor stars, looking at the stars in the database of the AAVSO. And visual observations of the star they were coming in, and they noticed that the star was dimming, which wasn't unusual, but then it started to dim significantly more than its usual pattern of dimming. And that's what alerted the professional astronomers to what's, something unusual is going on with Betelgeuse. So especially bright stars like that and bright stars like Epsilon Aurigae, they're very bright and they're actually hard to do digital photometry on. Like Epsilon Aurigae, I monitor with a DSLR. It's a little bit easier than trying to monitor it with a CCD camera.
Right. Wonderful. Wonderful. Thank you so much, Barbara. Thanks for taking
You're welcome.
the evening with us. Gary Albin says thank you. He's watching on YouTube. He says, looks forward to seeing you at the Winter Star Party in February. So we hope that you're there. Senthil Nagapan, I don't know where he's watching from, but anyways, he says very interesting. And anyways, it's great to have you on and to explore the universe of stars. It's wonderful. Okay, well, up next is Molly Wakeling. Molly I think Molly only once in person, okay, and it was at the Advanced Imaging Conference in San Jose, and then COVID kind of obscured our ability to meet face to face again. But when I saw her, I have mentioned this story before, she had this big beaming smile, and she had just got this print of her image of Rho Ophiuchus that she had done, and it was just spectacular. But what I can say is, and this is real, that Molly and I have become friends, although we've only been able to do this virtually through Zoom and these lectures and global star parties and stuff. But and I could have been more proud when she won first place in the Wilhelmina Fleming Award with the Astronomical League. So it's very well deserved. And I think you might be a judge for the next one. I'm not sure of that. So is
Yeah.
that
Yeah.
wonderful? Wonderful. So it'll be great. Okay, so I will turn this over to Molly Wakeling. Also, she runs the Astronomolly's Universe. You can find her on many different programs, but including her own website. So thank you, Molly.
Yeah, thanks for having me on again, Scott. And tonight's target, I was trying to think of something strange that I've imaged a couple of times, and decided that the Whirlpool Galaxy is strange-ish and has some, oops, my focus has gone a little fuzzy.
There we go.
Okay.
Good.
That it's got some really interesting aspects to it that I want to dive into. So I'll go ahead and get my screen shared here. Let's see. Yeah, let's do that one. And get my PowerPoint running. All right.
That was Minecraft.
Yeah, so tonight I'm talking about the Whirlpool Galaxy, and this is one of my most recent pictures of it here in the background. It's got a lot of cool stuff going on. So the Whirlpool Galaxy is a target that many amateur astronomers are I'm sure familiar with. It's also known as Messier 51, and it is a grand design spiral galaxy. So that means that the fact that it's a pure spiral and without any barred structure, and I think it also has to do with the number of arms and the fact that it has complete arms and things like that, make it this really phenomenal looking spiral galaxy that just looks like perfection. Where can you find M51? It's actually quite easy to find, even for people who are kind of star hopping novices like myself, who tend to use mostly computerized GoTo for all my work. If you go to the end of the handle of the Big Dipper, which is quite easy to find, and I think it's something like 2.5 or 3 degrees. I went and looked it up and I already forgot, away from the star at the end of the handle of the Big Dipper Alcade. And you kind of drop below the Big Dipper, and that's how you can, can't see my own cursor here. That's how you can find M51. It's pretty easy to hop to. You can also, while you're exploring M51, you can hop over to M101 as well, which is almost a little further above the star Alcade. So interesting facts, so some fast facts about the Whirlpool Galaxy. It's even though it's so close to the Big Dipper, it's not actually in the constellation Ursa Major. It's within the borders of Canis Venatici, which is a very galaxy-rich constellation that is a lot of fun to explore with a big enough telescope to see a lot of those galaxies. It's 31 million light years away. So that puts it outside of the local group, and it's got its own galaxy group. It was discovered by Charles Messier in 1773 and added to his catalog of things that one might mistake for comets that are not actually comets. Its spiral structure was discovered later by Lord Ross in, what did I read, 1780 something. Actually, it might have been later than that, might have been 1800s. I'm mixing up things. Okay, it's Tuesday. So Tuesday after holiday weekend. Has an apparent magnitude of 8.4, so it's relatively bright. And it's easy to at least see the fuzzball of it from a variety of skies. It's a target I typically hit up at public outreach events, even in the city. But and I've got some observing notes on it at the end, but you can see it in a wide variety of skies. And of course, the darker it is and the larger telescope you have, the more of it you can see to include its spiral structure. It is 76,000 light years across, which makes it about 3/4 of the diameter of the Milky Way. So it's a little bit smaller width-wise. So M51 is really interesting and strange because of its interaction with the very nearby galaxy NGC 5195. A lot of the time, 5195 is kind of considered part of M51 as the catalog object, but it is a separate galaxy. Now, it looks like, when you look at pictures of it, when you look at it in the eyepiece, it kind of looks like M51 is swallowing a 5195, like it's sucking it in, but that's not quite what's happening there. NGC 5195 is gravitationally interacting with M51. They orbit quite close to each other. I didn't get an exact figure, but it has passed through, like between, like kind of coming forward and back through M51 a couple of times, most recently sometime in the last 500 million years. It's located slightly behind M51 right now. And because of this gravitational interaction, it's causing a lot of interesting things to happen in both galaxies. So it's causing a lot of star formation to happen in M51, which is evidenced by all of the red regions that you can see in this Hubble image of M51. All of these red regions are star forming regions. And if you think about the number of bright red nebula that we have in our galaxy, there is a far greater number in M51 because of all this rapid star formation. And you'll see on the next slide, the star cloud that is formed because of this gravitational interaction of a lot of stars and dust being ejected from both of these galaxies. And NGC 5195 doesn't even really look like it has any structure. It's just been disrupted a lot. They're not sure whether it's always been an elliptical or if its structure was disrupted and it kind of became this way. I'm not sure. But another thing about 5195 is that it has a black hole in it that is actually burping out a lot of hydrogen gas. So not only do black holes accrete and sometimes gas and debris fall into them, but they can also kind of eject gas from their accretion disks. And because it's been swirling around their accretion disk and because of the physics involved, that gas can get very, very hot, very energized. And it's actually sweeping out cooler gas in front of it. And that's one of the other mechanisms that is spurring a lot of star formation in 5195. So this image here, it's actually an X-ray image inset of 5195. And this was some of the data used to observe that behavior in 5195, because that hot gas is glowing in X-ray. So you can see in this is one of my pictures here from the 2017 Texas Star Party with my DSLR, a good old trusty DSLR.
Yeah.
And you can see this kind of, I almost think it kind of a B shape or an E shape. It has some structure to it. Dust cloud, plus there's a tail going out here. And that's all ejected stars from these two galaxies because it's glowing. So there's probably dust in there too, but there's stars in here, which is crazy cool. Sorry, I meant to say September 2020. It's not September 2021 on this slide. In September 2020, a candidate exoplanet was discovered in M51. So in fact, all the exoplanet discoveries that have been made have been in our own galaxy, of course, because that's hard enough as it is to look for exoplanet transits and radial velocity shifts and things like that inside of our own galaxy. But this exoplanet candidate would be the first extragalactic planet yet known if it is confirmed. Now, we of course expect that other galaxies all have many exoplanets like our own. There's no reason why they wouldn't, but we haven't yet actually observed one. It was detected by observing eclipses of a high mass X-ray binary system that planet orbits. And that binary system itself is really cool because one of the stars is either a neutron star or a black hole. It's actually pretty difficult to tell the difference in a lot of these systems because both of them are very small, compact, dense sources. And the other one is likely a B-type supergiant. So on the scale of spectral types of stars, the mnemonic to remember them is, "Oh, be a fine guy, kiss me." And there's two other types, L and T. So I like to say LOL, TTYL. Or you can say "Be a fine gal, kiss me" if you're if that's what you prefer to do.
That's what you like.
Whichever you prefer. So on the beginning of that mnemonic, O, B, A, these are hotter, bluer stars, larger stars, and then over toward the K, M, K, and T and L stars, you're getting into small red stars, and then into brown dwarfs and whatnot. The sun is a G-type star, so kind of in the middle of that spectrum, yellow, main sequence, things like that. The planet is, they can tell that it's slightly smaller than the size of Saturn, and it orbits at some tens of astronomical units. So that would put it, it would be like a kind of similar distances to planets in our own solar system. Astronomical unit is the distance between the Earth and the sun, so about 10 times further away from the sun than the Earth is. So really cool system. I was reading the paper published on the archive about it, and they've got just tons and tons of data on this, and it's always amazing to me what we can figure out just from light. You know, we've seen a potential planet inside of another galaxy.
I know, that's mind-blowing. I mean, this galaxy is what, 25 million light years away?
31, yeah.
31, okay.
Yeah,
So
so here's some of the here's some images that were in that article on the archive. And so the left image is a little more zoomed out. It has the scale marking is an arc minute, and the X-ray source in question is inside of that dashed box. And then over here on the right, this is an X-ray image here on the left that's been colorized by the different X-ray energies or X-ray wavelengths. Over on the right is a Hubble image in, I think it's in optical light or near optical. That's at 10 arc seconds of the scale here. And the pink dot is where that star system is located, and right next to this kind of cluster here. And here's the actual eclipse data as the planet went in front of the binary star system. And they have lots of other plots showing other aspects of this, but this is the background subtracted one where you can see that, yeah, there's a dip there that looks relatively statistically significant. So it still needs to be confirmed with another method, but it's looking, oh, there's my kitty. Hello, kitty. His name is Apollo. Looking pretty good that there's probably something there. So I like to show pictures of what these objects look like in other wavelengths, because how we see them in the telescope and how we see them in most pictures from Hubble and from other astronomers is in the optical wavelengths, light that we can see with our eyes. But of course, there's a lot more to the electromagnetic spectrum than the light that we can see with our eyes. There's light ranging all the way from very low energy, long wavelength radio light all the way up to very high energy, short wavelength gamma light. So there's a lot of different types of radio images out there and a variety of frequencies, wavelengths. The one here on the left is actually the carbon monoxide, one of the carbon monoxide emission bands taken by a telescope in Spain, a radio telescope. And it's just kind of cool to see where this molecule is concentrated. And also to remember that elements in space, we're not just talking elements here. There's not just elemental hydrogen and oxygen and sulfur and things like that. There's a lot of chemistry going on in space, and a lot of organic molecules are made in these space environments. And here's one here, carbon monoxide, that we have here on Earth a lot from incompletely burning gases or fossil fuels like natural gas and gasoline and things like that. So it's really cool to see that also exists out in space. On the right is a kind of a close-up infrared image from the Hubble Space Telescope showing where a lot of the dust is at, and also peering through the dust to the bright infrared sources that are throughout that galaxy. Of course, we've already seen lots of pictures of the optical range, so I'm going to skip that and go to ultraviolet. I couldn't find a good picture on Google Images, so I used a piece of software called Aladdin that I have that has a visual database of a huge variety of different survey databases, everything from Hubble to Swift to Chandra and XMM Newton to just things all over the electromagnetic spectrum. So when I can't find an image easily on Google, I'll hop over there and see what is available from the huge variety of databases that are in the Aladdin software. And it's free, by the way. And here's an ultraviolet image. It looks like they've applied some color mapping to this. So they probably used a couple of different ultraviolet wavelengths from the Galex telescope. On the right is an X-ray image of the Whirlpool galaxy taken by the Chandra telescope. And you can see here at the core that there's some really interesting structure going on, as well as several bright X-ray sources. This is probably material around that black hole in NGC 5195, and lots of other hot stars and gas X-ray sources, things like that. Finally, to observe N51 visually, it's circumpolar above for people who are above 43 degrees north. For the rest of us in the Northern Hemisphere, it's best kind of between March and October. So for a lot of spring, summer, and fall. And that's kind of more to see it in the evening. If you get up early in the morning, you can see it for pretty much most of the year. It is visible with binoculars under dark skies as a smudge. In small telescopes, you can see its outline and you can see NGC 5195. And in larger instruments, you can actually make out the spiral structure. I got to look at it through a 36-inch Dobsonian at the Texas Star Party in 2018. I think it was 17 or 18. Yeah, actually, I think it was 17. No, I can't remember. Anyway, one of those years. And it looked like a picture of M51. It looked like kind of a bluish picture. I could see detail of the spiral structure. I could see the arm that appears to connect M51 to 5195. It was just absolutely mind-blowing. And I will also say, so a lot of times people say that the Andromeda Galaxy or M33, the Triangulum Galaxy, are the farthest objects you can see naked eye. This isn't quite true. Some people, myself included, have seen, I've seen M51 naked eye. I was in West Virginia. It was high in the sky. With averted vision, I saw a smudge kind of off the end of the tail of the Big Dipper. I thought at first maybe it was like an open cluster or a globular cluster. So I checked my star map and it's exactly where M51 was. So I did the technique of, you look away, you look back, see if it's still there, double, triple check the map. Yes, I saw M51 naked eye from West Virginia.
Wow.
That was so cool. The fact that it's 31 million light years away and you can see it naked eye under a dark sky is, oh man, it's so cool. Photographically, it's really excellent at a variety of fields of view. I've imaged it with my 530 millimeter long Takahashi telescope. I've imaged it with my 500 millimeter Borg telescope. I've imaged it with my 11-inch Schmidt-Cassegrain that is 2.8 meters of focal length. It's really excellent at a wide variety of focal lengths. Deep images, you can get it pretty easily with even just 30-second exposures because it is quite bright. But deep images reveal the extended star clouds coming off 5195, including some of the tidal features that are that kind of long stream coming off. And if you have like a hydrogen alpha filter, there are tons of H2 regions to get and add some really nice red and some really nice detailed structure to your color images. So it's a great photographic target and was one of my first astro imaging targets back when I was first starting out. I've imaged it 11 times now, because it's just such a nice target. It's so pretty.
Oh yeah. And you do
Here's-
such a good job.
Thank you. Here's one of my favorite images of it. I took this one when I was in West Virginia, when I saw it naked eye with my 76 millimeter Borg refractor. And it came out a little on the yellow side, but I quite like how much detail I got, even with the small refractor, how much of kind of the tidal stream I was able to get, and kind of that B-shaped star ejection region beside 5195. And yeah, I'm quite happy with this one. Oh yeah, and there's also several other galaxies in the area. Like I mentioned, it's in Canis Venatici, which is a very galaxy rich constellation. So you can see that there's a little guy here, there's one here, there's one here. And I'm sure if I took an even deeper exposure over multiple nights at this focal length, I would find even more galaxies buried in the background. And
I'm sure.
there's probably more in here that I haven't spotted as well. So yeah, that's M51. You can find me on the internet as Astronomally Images, and astronomally.com is my website.
Thank you very much, Molly. That's great. I posted a link to your website there, and we look forward to the next time you can come on. So, and good luck on your. I know you're working hard in your studies, so
yeah,
that's fantastic.
I think I might have to stick to every other week still. So.
Right. Oh yeah. Yes. But when
Smart
you can,
move.
that's great.
Yeah.
By the way, you were missed that Okie text, Molly.
I wish I could have gone. It's a big trip. It's a long, big trip for me.
I can attest to
and
that.
with classes and stuff like that. I wasn't going to make it back in time for classes to start. So
Yeah, I can attest to that. I just got back today.
oh yeah. And
So,
next year's a possibility though, because I won't be able to make the Texas Star Party, I don't think, because I'll be in class, but I'll be done with classes in June. So that will open up my at least remove some restrictions on when I can go do things, even though I'm going to be working very hard to work on my dissertation work. So I'll see what I can do.
yeah, get that dissertation done.
Yeah.
It took my wife some time to get hers done, and she finally got it. So keep working at it. It's important.
Yeah.
So
Okay, great. Next up here is Pekka Hautala from Stockholm, Sweden. He's been on many of our after parties for the Global Star Party, and has given a couple of featured talks with us. But Pekka, how are you? How's everything out there in Stockholm?
I'm fine, thanks, Scott team. Everything's fine, cloudy, rainy. So
Is that normal this time of year?
It's really normal, yeah. Stormy and so on. So I get stuff done like at home. And today, because I have lot of time to think and visualize about our universe, and I heard a small article about how we see the universe and Big Bang, and what I read that we all always think backwards to the beginning. We are researching what happened then, but it's hard to us to think that we are stardust. Everything is from stardust. And I begin to think from the Big Bang forwards. Then suddenly everything gets so clear that if you think all that stardust or materia and force flowing around, and then get a little bit closer together and begin to build some more mass and so on. And it's like thinking, if you think from adult to baby phase, that's difficult to imagine how to grow inwards. But it's very much easier to think from baby or pet dog to grown adult. And if you begin to think universe from Big Bang and forwards to our time, you can realize that there is small parts that has more matter and gravitation and mass, and then they are going to build a galaxy, and we have lots of those points, and inside the galaxy, the star for solar systems like ours, and there are like billions of them, maybe on each galaxy. And if you think more further from Big Bang, I was like thinking about, okay, black holes, what are they? Okay, if this universe grows and the mass grows, maybe the pressure inside the galaxies grows, and the black holes could be like vents that ventilates out the pressure. I don't know, but I do that kind of meditation during cloudy days, and everything becomes more clearer if you think like from the beginning to today, than from today to beginning. You have to go backwards. It's more, for me, it's more difficult to think like that than from beginning to this time. And the wonders even more is that there are planets without a mother star that's floating, and they are probably a size of Jupiter, and they're just looking for a mother star.
A rogue planet, yes.
Yeah.
Mhm.
And so everything that became from the Big Bang until today is unbelievable, hard to think clearly. But a good start is to begin from the Big Bang and then get some small places there is stardust and mass, and then build to what we have today. And we didn't just appear to the planet Earth. It is a long, it's like a galaxy builds. And when you think like that, 14.7 billion years, it's not so long time. It's quite short period of time when you think in cosmological time perspective. So I think the whole universe is just in the baby phase. So it's a lot more to come. That's
I think we can absolutely be assured of that.
yeah.
Absolutely.
So that's what I do daytime and nighttime when it's cloudy. And tomorrow I will, we have a clear day, so I will do some our close star observations and train me to next summer to get a little bit better images. But I will do my best.
I'm sure it'll be quite good. So
yeah.
Yep. Thank you,
Thanks
Pekka.
for having me.
Thank you very much. Thank you.
Thank you.
Great. Okay. We will take a 10-minute break, and we have more people coming up, including Deepti Gautam from Nepal, Adrian Bradley, Rodrigo Zelada, Cesar Brollo, and Maxi Falieres down in the Southern Hemisphere. So thanks for tuning in, and we'll be right back in about 10.
Good to see you, Maxi, again.
Hey, what's up, man? Hey, Adrian,
No,
how are you?
I'm back
You
from
look
my
a face that you have a big trip you done.
Yeah, it absolutely was a big trip, and it was fun though. I got a chance to see some Bortle 1 skies, and of course compared to what I have known, what so far. And I've got some more processing to do. I did a little bit of processing while I was there. I had a little tablet that had Lightroom, so I uploaded a few of the photos that I took. But I'm in the process of uploading photos now from my second camera, the one that's not modded. I uploaded pictures from my modded camera, so I'm still off work, so I have time to go through some of these images and see what I got. But the few that I did collect, that I did some quick work on, look very promising.
Excellent. I saw a couple of works of you that you upload on your Facebook page, and they are stunning. It's amazing.
The sky makes it very easy to do.
To be amazed.
Yeah, to be amazed. A lot of this stuff you see naked eye.
But I don't want to be a spoiler.
Yeah, it's
that
for
picture
those
that
that
I
already. Yeah, those that already haven't seen them.
Yes, that picture that I commented you. A couple of weeks ago when I went with two friends in farm skies, I remember saw it with my own eyes, and I never saw it that. And I'm glad that you have captured it in your camera, and well,
yeah,
that's
yeah, it's hard to describe, and that's in my presentation I'll mention, but it's very hard to describe what it's like to see the full night sky. It's one of the places that the Star Party's held is one of the few places touched by civilization, and so you're far enough away from any kind of lighting, man-made and otherwise, and it produces some beautiful sights at night. I did the little bitty test about how bright is the Milky Way, and I do have to say that I did see, it was faint, but I did see a shadow. I don't think I have one of the other pictures that I took quite ready, but the brightness of the Milky Way, I have a picture that looks like there's a full moon being covered by clouds. That's not a full moon, that's the Milky Way shining that brightly through the clouds.
Are you shooting with DSLR only?
Yeah, it's a DSLR. It's both wide field, and I've got a larger lens on a tracker, getting more narrow shots.
Yeah, I will order a Samyang 135 now. It they have stock in Finland. So
yes, that lens is killer.
Do you think, Molly, I can shoot with? I have asked you about the full modified, because full modified with the ordinary lens is hard to get focus. Because you don't have any lenses in the front.
Yeah, so when you do that, you pretty much just can't use autofocus anymore, which we don't really use much in Astro anyway.
Right.
I have used that lens with a modified Sony A7S before, and it worked fine.
Full modified?
Yeah.
Without clear glass. So
I don't know for sure whether it had the glass or not.
Yeah, because the glass, you put it's clear glass, and that makes that you reach focus. And my DSLR is pure naked.
Yeah.
Are there black holes at the centers of galaxies? If they are, how common are they? We simply didn't know.
Could astronomers ever hope to find what lurks at the centers of other galaxies, millions of light years away, as Goss did in our Milky Way?
5,
It would take another innovation in astronomy to make that possible.
and liftoff of the Space Shuttle Discovery with
Always
window on the universe.
When the Hubble Space Telescope starts delivering clear images of distant galaxies, a team of astronomers gets to work. They become known as the nukers because their focus is galactic nuclei, the centers of galaxies. One of them is Todd Lauer.
Step 1, we take a picture of a galaxy with the Hubble Space Telescope. It shows us where the stars in the galaxy are. It tells us its structure and exquisite resolution.
The key to finding supermassive black holes is to learn how fast the stars in the galaxy are moving. Galaxies outside our own are much too far away to measure the speed of individual stars. But by analyzing the way light is shifted from blue to red at different points in the galaxy, astronomers can put together an average speed of stars orbiting the center. It's accurate enough to create a replica in a computer.
The second step, where the real work begins, is to try to model the observations. And we actually do that by building models of galaxies in the computer.
It's known as Schwarzschild's method. Developed by Princeton astronomer Martin Schwarzschild, son of Carl Schwarzschild, whose mathematics first described the possibility of black holes.
Martin Schwarzschild's trick was he would actually build up a model of the galaxy that not only had where the mass was, but also had how the stars were moving.
For each galaxy they investigate, the nukers painstakingly build a computer model, and then using trial and error, adjust the parameters of mass and velocity, trying to make the model match the original observations they got from the Hubble.
And we say, let's try a star here, let's try one over here, let's have it go around this way, let's have this one go around that way. And we do this thousands and thousands of times until we build up a library of how stars can orbit in this galaxy. Success is when observations of the model match the observations taken with the Hubble Space Telescope.
But that doesn't happen. The models are missing something.
We try it again and again and again, all with no black hole yet, and say, gee, we really can't get the observations explained by the model.
Only when they add an enormous invisible mass at the galaxy's center does the model match the Hubble observations.
Almost always, we have to put in a black hole at the center. We can't match the observations without a black hole in the model.
Of roughly 36 galaxies that the nukers investigate, virtually all of them require a supermassive black hole. And since then, other observations have made us even more certain that supermassives and galaxies go together.
Every galaxy we've looked for one, we have found a supermassive black hole in its center.
It's a stunning revelation. Supermassives, once an entirely unexpected category of black holes, may be common.
Well, we are back, and it's the theme of our Global Star Party number 68 is Strange Universe, and so coming on all the way from Nepal is Deepti Gautam. She is from the Astronomical or the Nepal Astronomical Society, NASA, and she has been on many global star parties and has been a host of a global star party as well. And so that's been awesome. And so I'm going to turn it over to her Deepti often creates poetry, really nice, concise presentations, and she's done a great job. And so, Deepti, thank you very much for coming on to this 68th event.
Hello, everyone. It was really great. It was great to be back again after after missing lots of global party, because I was busy in the Old Space Week, as I am coordinating in my state province for the Old Space Week, managing the programs. And our theme is the strange universe. As we know, the universe seems strange itself, and its formation and all the things, like how we born, how we and all this, how it is linked with each other's everything. Now, I have a small point that is strange universe. They do not know why people born and die. Even a child doesn't know why does he cry. Why people walk and move here and there. They do not know even why do they fear. Care they take of each other's do not why. Thinking more on the many, break in the sky. Sky flies with star clouds filled with rain.
Oh, I hope we haven't lost Deepti.
Hopefully she comes back. Deepti.
Sometimes the internet
Hey,
is a little tough.
Nepal's a long ways away.
Nepal's a long ways away.
Science sources
That's
for
right.
galaxies and sleeps in.
Maybe.
Are you listening to me?
Okay.
Yeah, we can hear you.
We hear you now.
Okay.
And we see you.
We got cut off during your poem.
It's something in the universe wanted to try and stop you. We can't let that happen. Carry on.
Carry on. Yes.
Science searches for many galaxies and planets. Some sleep in a cold for pleasures in cover blankets. Some got some foods. Some get food. Some do not at all and fall down. One become lever, another wear sure crown. Soul does action but doesn't able to know. Snow falls on hill like attitude. Soul does so. Soul again goes away from body, enter another's. He travels in between birth and death further. Stars and planets are hung in space in dark matters, never fall down, ever more in the track, it's look better. Force of gravitation control walking of us on Earth. God knows all secrets of strange universe and Earth. It was my poem, and I want to show some glimpse. I was working for All Space Week. Entire this week or entire this last 2 weeks. Can you see my screen?
Yes. Yeah, you might want to take it into present. There you go. Okay. Very good.
As I was working in the Old Swiss Week since last 2 weeks and moderating the programs, different programs around my province, around my locality. Old Swiss Week, October 4 to 10, and this is my 60 telescope, which I have taken in the observation programs, observing the Jupiters and Moon and the Sun using the solar filter. Similarly, this is the glimpse by which I have taken in this observation program. It is night sky observations. Around 6:30 p.m. We have shown the moon to this kid, and these are the kid from the orphanage. They didn't have the parents, and in this small, they lost their parents in a small age, and the organization is helping them and caring them, and and all the organization is caring them and giving them educations, etc. And while we go to there and teach them about the space and astronomy and show them the moon, Jupiter, and their excitement level was so high, and it was so great to look them and to look them very carefully, like how they see it mutually and understanding by having mutual understanding each others, and how they see it while we were leaving from these organizations, and we were busy in the terrace for some hours, and after we go to the down in the room, and some were making the drinks, some were looking up the cartoons, and some were playing with each others, and okay.
Cool.
And this is the clips that is of the one boy who was very excited to see the moon. First of all, he was say, I want to look from finder scope, so we let him. Okay, you can see from finder scope, and he was so excited to see the moon. And this is the programs that we have. Then is this also the moon observations around the 6 p.m. or 6:30 p.m. In the evening in the school. We have taken this small kids. It was a holiday. Though it was a holiday, but these kids were invited for the observation, and they came and they really enjoyed. And next is this is the program that is presentation making competitions in the school, that is in the topic of introduction to astrophysics. And in these programs, this program was held in my school. I was the organizer, and I handled all the programs about the presentation making competition. All my juniors and my friends were participated in this program, and all my teachers and all the lecturers, professors were there to look up. And the professor of the finance, he was not from the science faculty, though the professor of the finance was present there, and he explained how he loved. He said that I'm not from this field, but I really love this space and science after listening my students. And, he really loved all this presentation by the students, and he was excited to know how the life forms and all this universe fact. And as he explained me later on, I was so excited, and he expected all programs. And here's the finance teachers sitting here, finance teacher, and he was so excited, and he sit in this program all these programs and listen carefully to all the students, and he got so excited. And he is my science teachers, and he was there for judgment of the students on the programs. And this month of all this glimpse, and today I'm going for this night sky observations in another orphanage home, and looking up more excited and to see this excited kids, and to expecting to teach them more. And I have also tried sidewalk astronomy. I set up my telescope and take in the outside of my home, and I was putting this telescope there, and my small kid was there, and he said, "Oh, what's that?" And I said, "It's a telescope." And he was like, "Can you see the moon? Can you see the Jupiter? And can I see?" And okay, I let him. Yes, of course you can see. And when he kept his eyes in the eyepiece, and he was like, "Whoa, it's the moon!" And what's that in the moon? I said, "It's the crater." And okay, and is there any craters in the moon and anything, or what is that black spot in the moon? And he said, I also want to see the Jupiter. And I turned out of the telescope into the Jupiters. And what he said, from my telescope, I can see this Jupiters very finely, but I can see the round shape and not clearly because it's a 60 telescope. So when he see this Jupiters and moon, and I invited him for the solar observation next morning. You can come for the solar observation because he sits nearest to my home. And he comes to near early morning and see okay, sis, I want to see the sun. As you have promised me yesterday. And okay, I showed him the sun too. And like when you see the black spot, sun spot in the sun, he was like, "Oh, does the sun have this spot? We can't see this spot here." And like all those old men and grandfathers all were there for seeing this moon. And as they believe in a traditional belief, and they were like making joke like, am I going to pray this moon? Can I take anything to pray? Okay, and they were related with the astronomy and traditional astronomy. They believe in this traditional astronomy, and I said them always and creators, and it was really fun to take the telescope and observation in the public place and teach the people what is this, and to share them about the astronomy and space science. Thank you.
Thank you so much, Deepti. It's great. It's great. We had at times some interruption in the internet, but right now it's very good. So remarkable, really. So thank you so much. And it's wonderful. It's really wonderful to see, the children getting involved with astronomy, and for NASA to cross the bridge to all people of all ages. So it's wonderful. It's wonderful. Are you spending more time with NASA and in presentations? I mean, it seems to be a very active club.
Yeah, I'm involving in All Space Week. Is actually the national coordinator of All Space Week is Mansa Dwarem. She has been here in the next in the previous Easter party. And he sees the national coordinator, and she decided to divide the work in all the province. We have 7 province or called state in the Nepal, and she divided all this province to each of the member of the NASA, junior member of the NASA, and all the affiliate member of the NASA. And I am handling my province all around this. I have 12 district that is in our province, and I have been going attending all the presentation programs and night sky observation or solar observations. I'm handling, and today, as I'm invited for as I'm coordinators and people invites me in this different school college, and me with my some of friends that is Pritesh Thakur and all this team. We have team from and around here, and we go together and conduct the programs and return back like we are conducting through the NASA. It is World Space Week. This province coordinator are affiliated with directly, indirectly with the NASA, and NASA is handling like Suresh Watrai, the chairperson of NASA, is helping us, though he is not connected with the World Space Week. But he's helping us directly and in the every phases. So, and beside this, we are making the outreach not only for the World Space Week, but for the promotion of the space science and astronomy. So yeah, I'm connected with World Space Week, that is our events, and NASA and my own organizations. That is me with my team from my organizations, where is helping me out here for observation program. They comes together and teach the people, small kid and elderly people, so what astronomy is. And we collectively working from the NASA and my own organization, that is AN, Astronomy Enthusiast in Nepal, and in the event of World Space Week for now.
Wow. Okay. All right. That's great. All right, Deepti, thank you so much. That's great. We hope to see you maybe next week. I don't know if what your availability is like, but it's always a pleasure to have you on Global Star Party. Thank you so much. Thank you. All right. Let's bring on Adrian Bradley. Adrian's just coming back from the Texas Okie Tech Star Party, not the Texas Star Party. Okay, Okie Techs. And so, what did you think? It was your first time, I think, right?
Yes, it was, and I enjoyed it. couple things that I remember being really cold the first night in the RV, asking around for sleeping bags and blankets, and that made the experience a little better.
That's good.
Um,
People
and
there are very helpful, I think.
yes, they are.
Yeah.
The showers are warm. The tarantulas are cool to see as they
Yes.
walk through the, you see them kind of on the fringes of the property.
Right.
And all they're trying to do is get back home before being stepped on.
Sure.
And the hospitality, and there's so many people there. The group that I went with, University Lowbrow Astronomers, and I had to give a shout out to Camp Lowbrow. We were there. They had been going when there was mostly visual at Okie-Tex, and it's become there's a lot of astrophotography that goes on at Okie-Tex. So for them, it's a little bit of it's a sad change, but it's kind of the way things are. When you go to star parties, you see a lot more folks coming in with huge computer setups and tents, and if something goes wrong, as it invariably does during the night, you click on a bright light, and then the visual astronomers yell, "Turn off that light!" And it can get a little testy, but by the time the night's going, usually everyone's into the night. So I will, as anticipated, share the screen. Some of you, I know Harold Locke is out there, a couple of others. Some of you have seen some of the pictures because I went ahead and shared them while I was out there, out at Okie-Tex, and on our way back. I shared a few photos. So I will describe what I've got here and try to go in chronological order. First, this image. Most of us aren't able to get a Milky Way shot using our iPhone. Why this isn't coming up? Okay, it's coming up over here. And this was the best I could do.
That's pretty
with
good.
An iPhone. Keeping in mind
that's an iPhone. That's an
the
iPhone.
I'd like you to try this at your home state or home area.
Wow.
This is one of the shots that basically lets you know just how bright the Milky Way is.
Yeah.
It's bright enough to be.
Adrian, you got to send that to Apple. Really. I mean,
I will send that to Apple, definitely. They can say, yeah, and if they want to use it for marketing purposes, I'm sure they will.
That's right.
How long of exposure is that?
That was a 30-second exposure on a tracker, putting the iPhone on a star tracker.
Barbara, would you ever believe, 10, 15 years ago that you could do that with a phone? I mean, come on.
I know. Incredible.
Yeah, that was my experiment to see that there were a number of pictures I took just to indicate how bright the Milky Way was. I'm going to show you a picture. Now, this is the brightest Milky Way I had to date, and actually the terrain looks similar in Okie-Tex. This was at a Bortle 2 sky after a minute. So comparing what you see here to what I took with an iPhone in 30 seconds, that's the difference. This is, and I'll do a prelude. This is, if it loads, a picture of the other side of the Milky Way that I'm trying to load here, and it will eventually. Orion, and this was with a non-modded camera. And that was about a minute or so exposure to get that.
Where was that taken, Adrian?
That was taken at in Michigan, Port Austin, near the thumb. So comparing that to this close-up of the Milky Way core, this was a minute-long exposure at Okie-Tex.
At Okie-Tex.
And
wow.
There you go.
Gorgeous.
That is.
Yeah, I knew you were going to take some pretty mind-blowing, night sky photography like this. So it is for any of you who have not been to Okie-Tex or the Black Mesa State Park in the Panhandle of Oklahoma, folks, it's dark, real dark, and real clear. You're up about 4,000 feet.
Yeah, you are. 4,000.
you're not up so high that altitude is a problem for you, but the transparency is awesome and it's beautiful.
So here's another proof of concept thing. Clouds came the first night, and this is what it looks like. You're at the northeastern corner of the field where the star party's held. This was a wide angle lens. You can see some of the distortion, and you see this shining through. This is something else you probably won't see at your regular sky, depending on where you are, unless you're out in a place like this. The glow of the Milky Way shining through the clouds, the glow
You think
of
it's
Jupiter.
light pollution,
Yeah, it's not. it's the glow of the Milky Way. And
Milky
you
Way
mentioned,
pollution.
yep, it's Milky Way pollution. You have, let's see, you mentioned something here. I think this image is the other side. And you've got this. Normally, this would be your light pollution. This is air glow that the camera picked up.
Yeah.
And there's all sorts of, so I used a HA modified camera. So you've got the hydrogen alpha data of things coming through here.
Look at that. The Milky Way is like a dagger coming into this beautiful, like a pool of effervescent green coming down through there. And then this beautiful, landscape of the plateaus and stuff out at Black Mesa.
Yes.
So it's beautiful. And it looks like you got the Andromeda Galaxy or something off to the side.
I did. I'll fire that back up. That you got the Andromeda Galaxy just sitting over here, and M33 over here.
Okay.
The Triangulum Galaxy is over here. NGC 752, the double cluster,
Amazing.
and the Heart and Soul nebulas, which a lot of visual astronomers tried to view and they couldn't. And they'd get asked, are you trying to do imaging? Because the hydrogen alpha, the light output tends to only be visible if you've got a camera picking up that light.
Right.
Then there's a lot of there are nebulas here that I still haven't looked up to say what they are, but they all shine through.
There was
Norm Hughes is, go ahead.
There was not many IDA, International Dark Association's members there, I probably think.
Yeah, there were. So here's one, when you wait for Orion to rise. And go ahead, Scott, you were saying someone had a comment.
Oh, yeah, it's Norm Hughes watching on YouTube. He says, I've been to the park, but not to Okie-Tex. Been here all my life and haven't gone to Okie-Tex. Crazy. Dude, you got to go. You gotta go. I've been many times. It is I can attest, after being around the country, around the world, this is one of the darkest sites that you can go to. It's really great.
Yeah, all of these are roughly 30 seconds. It's easy to get data, we'll call it. There's California, the Pleiades. Someone pointed to me that this void, you see sort of this shape around the Pleiades, does exist. It's a bit of a void in that part of the galaxy. Now the pictures are pretty rough. I actually am gonna process them directly, and so they'll come out a little clearer. So you've got the air glow, you've got Orion rising, and all of the data that comes, with Barnard's loop. So the moment of, and here's a close-up. If it comes in, a close-up of the Heart and Soul. This is a single 1 minute frame.
Okay.
Double cluster, Heart and Soul.
All right. Now, can you go back to the previous image one more time?
Yes. Let's go get it. If I find it. Here it is. I called it Orion Rise.
So you have a detail of that. But look at this, and when you look at it, just look at the whole view of it, because now what you start to see is like this formation in the center, like it's like you're looking at an Orion Nebula or something, or some sort of matrix of bright nebula and dark nebula, and it looks like one kind of object, and it's just beautiful. It is beautiful. This is something you could sit in front of and contemplate for hours, really.
it's a part of the Milky Way that Milky Way shooters typically don't shoot this part of the Milky Way. I did see one, the Southern Hemisphere gets to see this view. We get to see this view a lot more in our hemisphere, the Northern Hemisphere. And you go to a dark site to truly appreciate it. And I'll show you the shot of a couple shots that I kind of itching to show, and I'm trying to hold the good one for last. I thought I had an Orion rise with a regular modded camera. Here's the same area with a camera that doesn't get modded, and this is what you can still get in roughly 30 seconds. We had some haze the final night, so it produced this image. You still have air glow, and there are the dust lanes. Even in an unmodded camera, there's a bit of a void.
Right.
And because of the haze, you could get this cool effect with the larger stars as Orion rises. So there's it there. Even if you don't have a modified DSLR, or you're not using a wide field lens on an astro camera, you can still take beautiful pictures using the camera you have. And now for let's see, there are a couple star trails. There's one, the Mesa. This was about a 15-minute exposure. Those of us that love star trails, here you go. And this Milky Way picture, to me, also defines how bright the Milky Way is. Look at this detail. Wow. And look at this twilight.
You know, if there was a coffee table book on the Okie-Tex Star Party, this should be on the cover. I mean, absolutely beautiful. It shows the Star Party field, the people interacting there, you know, the red lights that amateur astronomers use, and this amazing, the drive of again, the dagger coming into from the sky down to the Star Party. Some clouds in the background to kind of give you a terrestrial feel, you know? Yep. And then you've got this meteor that's streaking across the sky. Really beautiful, amazing.
Yep, and amazing to me is how visible the Milky Way is, and how twilight still hasn't stopped yet.
Yeah, it's not quite dark yet.
Yeah, it's bright over here.
Yeah.
So this was one of the shots of the night.
That's not from a city. That's from the sun.
Yeah, exactly. And so yeah, this much detail, you usually have to wait till you get dark enough, even in that Bortle 2 sky, before you see this. But the Milky Way pops out at you when you go to a place like this. And what else pops out at you, before I click on this picture, the story goes like this. I woke up at around 5. I was just tired. I was cold. And I got up, walked outside, and I saw this. If it'll come up in a couple minutes, but I was floored when I saw Orion over this hill, Winter Milky Way and Zodiacal Light crossing.
Look at that. That's beautiful.
And this picture doesn't even do it
Oh, I
justice.
love that.
Yeah.
So I said, I guess I got to take a picture. Walked back into the sleepy-eyed, got the camera, 30, set it up, went a 30-second exposure, did a little bit of editing so you could see this. Oki and Tex are the two flamingos, and they're over here somewhere. They get put up there. There were a lot of photographers that started going up here and up over the other buttes to get beautiful photos.
Yeah.
But I would challenge them, if they'd stayed on the ground and were up at 5 in the morning to see this, you wouldn't even need to be up here. You can get just as beautiful a picture. And of course, when you use a modified camera, Orion is exposed, and you can see more of the details there.
Now, so, Barbara, what do you think of just that
here, I'll put this back up.
Gradual gradient of light getting darker and darker, but starting to show like these bubbles of nebulosity and the zodiacal light coming across. It's just super.
I know, it's really incredible.
Yeah. It's,
I just took a picture of the zodiacal light last month for the first time. I got up early.
yeah.
It is, yeah, and you got up early to do it. I took mine, my first zodiacal light in Michigan. It was spring equinox, and as I went out, I noticed it and took it, of course, going the other way with sunset along the ecliptic. So I, instantly recognizing this. What you're not seeing, and what I tried to capture, but I still have to process, a crescent moon with Earthshine coming up over the horizon,
right,
and in the zodiacal light. So that
Wow.
picture is forthcoming if I'm able, and it may have to be a composite, but that picture is one that I hope to be able to share if I took it. I took a few frames. I wasn't happy, but I did my best to capture the moon itself, as well as the just being in the zodiacal light. So that's coming up. This is my friend's trailer and some more star trails. I took a few different exposures, so when I layer these together, chances are the star trails are going to look a lot longer than
it's
this.
beautiful as it is. I have to, really tip my hat to you, Adrian, because you're capturing a feel of the Okie-Tex Star Party that really, this is the first time I've seen it photographically,
Yeah.
I've seen a lot of photographs taken, images taken from Okie-Tex. Okay. But, seeing these wide field views, the amazing, spectacular effects of the Milky Way. These are things that you actually can start to visually see, except for these colors. The colors are now coming out because of photography. Adrian talked a little bit about, doing, mixing some images, or doing a montage, not a montage, but also, layering in some images, to capture the moon and stuff. And sometimes you have to do that because in photography, and you guys that do imaging know this, you only have a certain range and then it stops.
Yeah.
Right. And then you have to go into a different exposure, deeper, and start to mix these images together to try to capture what you can see visually, or how it impacts you, how it impacts you from seeing it, and so it's not like photo magic or something, but these are the tools that astrophotographers have to use to convey, to translate the feeling.
Yeah, when we want to show something as we saw it, sometimes we have to put, like Scott said, put some of the pictures together because of the dynamic range of the camera. Sometimes we don't, and sometimes it can surprise us depending on its knowledge of your camera and how bright things are. I'll end on this picture. For those out there that do have, as I do, we have, we're part of a church, and we think of the universe both in and of itself and then spiritually with God. Those of you out there that don't can look at this and just notice, this is a beautiful picture. If you know anything about camera photography, you would expect this to have been a 30-second exposure. This was an 8-second exposure.
Wow.
An 8-second exposure on a tripod with ISO turned all the way up to 8,000 with a 50 millimeter lens. f1.4 was the aperture setting, and I went for 8 seconds, fired with the cross in this part of the mesa, basically a little hill in the background, and look how much detail I got. Now, wasn't perfect, but just right over here, if we stop here right over the cross, if you think about it, most Milky Way shooters are not going to go for 8 seconds out wherever you are, and you really don't really get to do that unless it's so dark and the Milky Way is so bright that even in 8 seconds, you can still get this much detail, this much nebulosity going on. There's M8, M20. I believe these are, and I see Gary has joined us, could tell me if the M7, I think 17, M16, there's something here. Again, walking up the Milky Way is something that I would love to do, but just haven't spent enough time getting all of these objects. And there's actually a couple clouds. I don't think this is a part of the Milky Way. A couple of the clouds here are just dark. They're in a lot of places, they may be lit by whatever light pollution or, local cities are there. But here, the clouds are just dark. So stars just sort of disappear as clouds go over them. And that's, is the old, this shot that Scott loves. I'll have to send this one to you, Scott. You got the clouds.
Yeah, I'll print it and have it on my wall. It's great.
Yeah, I'll get you the high resolution copy.
Okay.
And you've got Milky Way here. The sun, the twilight has not fully gone. I've got some hot pixels here.
No, but it's cool. It is.
Yep.
You don't need it gone. In fact,
yeah,
it's perfect like it is. So
that's cool. The offshore one telescope under the cover, Adrian.
Yeah, this one
Yes.
hasn't been. Yep, they haven't opened it up yet.
Yeah,
so
Pekka,
I think
you're from the United States.
Yeah, this is a little closer view. I said I'd end. Here's your closer view. I got into my hiding spot so I wouldn't be shining lights on anyone, and you get a little more Milky Way than you do where I am at 41st parallel. I think this is 39th parallel. And this was a 30-second exposure. There's some other there's a ghost here because the first night, one of my friends from our Camp Lowbrow did a little bit of imaging himself, and then he went to purely visual astronomy. And that's where everyone else was. I went out and got a few more shots, but so this was also day one after some of the clouds had disappeared.
Right.
And comparing this in 30 seconds to this in 1 minute gives you sort of the idea of what it takes to get the Milky Way at a dark sky. A lot of data just comes at you. You don't require as much time to get the same amount of data. And that, when it goes to classic astrophotography or wide field, imaging on a tracker, dark skies, things that you can do with dark skies is it shortens your time and capture. Here's one more iPhone Milky Way, which will come up in probably 10 seconds. At least I think it will. Yeah, another, it's a very crude photo. It's something
dramatic. It is.
Yeah, this was handheld. And so that's handheld, and the glow of the Milky Way still shows up through your iPhone.
That's amazing.
So that's
amazing.
how bright the Milky Way is there. Yeah. And I think I've shown all these photos here. So that concludes. Gary, you'll laugh at this one. I didn't show this one, and this is why. Because this was my 1 minute attempt at getting the belt while I was there, and this is what I got.
You got the flame. You have the Orion.
There's a horse head right there.
Exactly.
Yeah,
Ancient of Barnard's Loop. So, yep.
So, and then I think a dust spot on my lens. So, yep, and that's how I got round stars. So it was a good start, and then I just went into other stuff. So
Adrian, I wish all my friends that are astronomy friends that have passed on could see your images, because they would be utterly blown away. They really would, so
yeah. And this is this is the one that I love the most.
You guys watching it right now live, just soak it in, because it's awesome.
Yeah, and then go out and see it for yourself. This is mostly what I saw. Now I had the HA modded camera, so you got some more. You undress the drawing a bit, and you got some more detail. There's the rosette right here.
Mhm.
Like the pelicans over here somewhere, and so you've got a little more detail, a little more red in the photo. But when I tell you I stood there and this is what I saw,
Yeah.
just imagine seeing it. You may not see all of the, all of this detail, but you would see all of the stars, and the Milky Way was that visible. And so was the Diacal Light.
It's sacred, and when you say it's spiritual, it absolutely is. This stuff strikes you to the core, and this is why people go to really dark sites, and this is why we need to protect our dark skies.
Yes, that's a great note for me to end my presentation on. Thank you, Scott, for your annotations, and to all of you here, Pekka, Gary, Cesar, Maxi, Rodrigo, and Barbara. Thank you for your kind comments. Looking forward to seeing your work. Don't have to go to work for another few days, so I can hang out and listen in. So thank you all.
Adrian. Yeah. So next time, if you're looking for an amazing astronomy experience, go to the Okie-Tex Star Party. It's super, super amazing, super dark. And they often have many back-to-back nights of clear skies. So wonderful. Okay. All right. So we are moving on to Rodrigo Zelada down in Chile. Rodrigo is, someone that he's still the owner of North Optics down in La Serena, but he still does backyard amateur astrophotography, but he's becoming a professional astronomer, a professional researcher, and it's great to have him on Global Star Party. Thank you, Rodrigo.
Hi, Scott. How are you?
Yes.
Yep, we can see you, Rodrigo.
Hi, how are you? This night I share with you my live picture from my backyard, and the Orion Nebula is the great object for photography, and I take the picture from 2 days ago, and it's a very nice picture. I will use my screen in a few minutes. Okay.
Yep, we can see it.
Do you see my screen now?
We do. I see some beautiful images of M42 and 43 and NGC 1977.
Yes, this is my final image. This picture is take the Saturday and the night when my refractive telescope from La Serena in the city in my backyard. It's a nice photo for Orion Nebula. It's very difficult to the center is very bright, and it's very difficult reduce the light in the center. And this is my last picture.
Wow, look at that.
This picture is for little time. It's 20 photo to 20 seconds. In the center, you see the trapezium
Museum, yes.
Yes,
Mhm. Mhm. Beautiful.
and my plan is with this result, with 20 seconds for imagine, is take 4 hours, 20 seconds.
Mm.
And in the last start party, I plan to share with you the photo of the M17 in the Sagittarius. I work for the data of the professional telescope in Chile. It's a Vista telescope. This telescope is work in infrared, and I see the nebula in infrared is very nice, and share with you this photo. This photo is
Oh, wow.
is a comparison for the sector of the Messier 17. This sector is visible light, and this sector is in near infrared. And
wow.
This is the.
Now, Rodrigo, could you explain a little bit more? We're looking at the visual image and the near infrared. Why is the parts of it kind of this more dark brown color, and then we have this cooler blue color? Is it because of the any energy or temperature differences? What's happening here?
Well, in the near infrared, this color is false color. Is the light is the light blue is for near to the visible, and the brown is more near to the infrared.
More in the infrared. Okay, interesting. Because you start to see areas which I think are star formation. You know, those dark tendrils of dust that are coming in, and probably at the tips of them, and maybe towards the edges, are primordial stars or newborn stars, right?
The light infrared is more transparent for the dust in the galaxy, and this area is dust and blocking the light spectrum in the visible spectrum. In infrared, this is transparent for the dust in the galaxy. This project BBX is for study the variable star, and this telescope is a survey, take many pictures, and the astronomer using this picture for another study for a global cluster, and study the new galaxy. It's not visible for the dust in the galaxy. And this picture is in this area in the Sagittarius, and this nebula is M17.
Wow.
It's completamente different what you like in the visible light.
Look at the dark nebulosity, up towards the top and left, and it just makes it in stark contrast to really bring out this nebula. But it's just, it's scattered with all these beautiful stars. It's amazing,
Yes.
Amazing.
This area is the
oh, yes. And so you can see also the star formation areas.
Star formation, yes.
Yes. Right. Yes. How does this make you feel, Rodrigo, when you see an image like this?
when I open first images and process,
Yeah.
it's amazing.
Yeah.
I process now about the cerca de 500 imágenes. And
500.
Claro, 500 this moment is amazing. It's first time and I see the strokes on galaxy and stars. New for me and for astronomers. It's new images. It's very
yes. You know, it's hard to describe such an amazing image like this, because you know, an astronomer like Rodrigo, he knows a lot of what's going on in the background, but trying to verbalize that, okay, beyond saying amazing, okay, is just really tough, because this is creation. You know, this is creation, this is destruction, you are at once seeing the entire dynamic of what's going on in star formation and the star cycle, you know, and it's it grabs the you know, or captures the understanding and the moment and everything that it just takes it beyond words. It really does. So, and then I'm not trying to be real tongue in cheek about this, but this is these images and to witness this kind of stuff is really fundamental to what drives astronomers to understand more and more and more about star formation and what drives our universe.
Yes, and the most impressive image is in the disk of the galaxy, the Milky Way. In this image in near infrared, you see many galaxies. Your light is blocked for the Milky Way. In the infrared, the dust is transparent, and you see the more galaxy in the field.
It's beautiful.
This is my presentation, Scott.
Rodrigo, thank you so much. That's wonderful. That's wonderful. I know that Cesar and Maxi are waiting, but Gary Palmer is out there, and it's quite early in the morning. Gary, did you want to share anything with us?
Hi, Scott. Nice to see everybody on here again. I'm up late anyway. I've been running a workshop this evening, or overnight here. So we're sort of ticking along. So a few bits this week. Done some solar. Weather's not been brilliant. We've got a change of season now, so we're starting to get the fog come through, get a couple of hours clear, or the days are a little bit hazy for solar. But I'll share a screen over. So been doing some more work on this 3D system on the solar.
Oh, wow.
So we can actually see that generally when you look at this two-dimensional, you'll just see the prominence like that on the edge of the limb. And this would be the same. If you image this on a standard system, you can't actually see that this is coming back onto the surface. It's very hard to actually see the filament there, and that the filaments are drawing off of each other. So still needs a little bit more work on it, but that's detailed with one of the suns.
Wow. That's amazing.
That's using the double stack system. It's only 80mm aperture, so it's pretty close up for 80mm at this time of year.
Incredible.
Go to the standard system. So this is a Qualcomm the FCD 102.
Yeah.
You'll see it's there, but the double stacking just adds the contrast. That's the big difference between the two images. And also you pull out the active areas. So if there's any areas with flares or things like that, you can really see those starting to react on what's going on.
You know, more and more of these kinds of images, these incredibly high resolution images of the sun have been coming out from guys like Gary and a few others, but Gary is really, really at the, you know, leading the pack in a lot of these guys doing this kind of imaging. It is because he spends so much time understanding the equipment, improving his skills, including his basic skills, but and teaching others. You know, by teaching others, your skill level gets higher and higher by doing that. But you know, you're staring right down into you know, the cauldron of a fusion reaction. You know, it's amazing.
Thanks. It just takes. I think it takes patience. That's the same with all of this. It's really about patience, looking at what's going on, looking at the images that are coming in, and working out whether you can change anything, whether you can improve on that, or whether, you know, something in the equipment can change. You know, it's not all based around the weather. I thought we'd put this up and have a quick look at this. This was an hour's worth of data last night on M33. And just run through and see what's there for an hour, you know, so we can just run off. We've already stacked and calibrated the image, but if we did a quick photometric color calibration on it, we can set it up. So if we go in, type the object number, it's M33, search it out. At that, we need to acquire the pixel size for the camera, and then the focal length of the equipment is about 500 millimeter. So I've heard a few people complaining that this is not working. This photometric color calibration are getting problems. It's normally in the focal length. You know, if you have to work out that if you put a reducer on the system, your focal length's changed. And this is actually going to plate solve it off of a database. So it needs to be fairly correct. It's going to solve against the stars that are in your image against a database that's held. And once you've put in the actual target, the pixel size and the focal length, it's pretty straightforward. You just apply it to the image. It will go off, it will reference, it'll download the data, upload your image, and then it will work it out from there. And it'll color calibrate, and it's a fairly good system because it's calibrating it on the night sky. That's on record. So any changes that go on there, then it will be updated in your images. So it takes a couple of seconds for it to go through, but it's fairly straightforward.
And Gary, this is another featured Pixin site, right?
Yeah. I mean, I've played with lots of different software. I played with AstroPixel processor. We did some tests on that, and the new weighted batch process or script in PixInsight is far quicker now. You know, people used to use AstroPixel processor and Deep Sky Stacker because they didn't like the amount of time. But I always say good things come to those who wait. Yeah, so if you're prepared to wait, you're going to get the benefit out of it. So that's the image calibrated, still raw, so we need to brighten it up a little bit to see what's going on. And so next thing is really a little bit of work on the noise in the background, because if we zoom into it, we can see it's a little bit speckly. It was a little bit foggy last night. There was like bits of sort of mist and fog coming through, so they're going to affect that. And it's pretty straightforward to do this as well. So we can just go in, screen transfer function, and then we want multi-scale linear transform, and just set this up. So this is pretty straightforward. Start off on noise reduction. We've got 4 layers there. First one starts on 3. All of these are around 50%. So next layer, noise reduction, we come down to 2. Same thing again, 50%. This is one of the easiest processes for combating noise or high gain off of cameras. You can get all sorts of artifacts. Some filters actually create a lot of background noise just in their generic design. So these new extreme filters, the dual band filters, they're very noisy. So down to 1 for the third layer, and the last one, yeah, if we click on it, go to noise reduction, bring it into 0.5, which is half. There we go. And then the same thing again, 50%. So with the image being linear or raw, it's not stretched yet. And if we use any mask on this, it has to be stretched. The easiest way to make the mask is use the clone tool up the top. This will give you a black and white mask, but we need to stretch that to be able to use it. Otherwise it can't mask anything off. So if we use the histogram, don't know what happened there. Histogram tool, select the mask. Okay, then activate this, and with your screen transfer function, hit the nuclear button. That puts a false intensity in here.
Oh, wow.
And we can transfer that into the histogram. So we don't need to do any settings or anything. All we need to do before we apply the histogram is reset the main image. We were only using that for the light intensity. That image is permanently stretched now. So you could even post that out on social media. You know, once it's at that point, away it goes, but we're going to use it for a mask. So bring it across, attach it to the name bar, select the main image. And now what we need to do to apply the noise reduction, just move that up out there, we need to invert it. So we've got our mask controls here. We're going to invert the mask so it's covering the objects in the stars.
Oh.
And then this just removes the visual effect of the mask. It's still active, got the orange bar at the top. And then we apply the morphological multi-scale transformation. And that, you'll see, it makes a massive difference to the noise.
Gary, hey, how are you?
I'm good, thanks. Yourself?
Can I ask you a question? You don't convolutionate the mask?
No, this really, at the end of the day, you have to look at it at how much data you've got. So if you've only really got an hour or an hour and a bit's worth of data, there's only so much you're going to do with it. And that's the same with any image. It's like Adrian. If you've got an image that's a minute, yeah, and you've got an image that's 5 minutes, there's so much more you can do with that image that's 5 minutes. The image that's a minute, you can only do so much with it. So you have to ask yourself, is it really worth it? And that's the key thing. If I had 10 hours worth of data here, then I'd spend a lot longer on this. But that's the big difference with this sort of thing. So if we zoom into that and go over to the edge, and then we go back, you'll see that it's flattened down the background. So it's smoothed everything out. It's taken off the harsh edges on the stars. That makes it a lot more appealing. What we can do now, just going to drop this down so we can close the mask off. There we go. So we're at the point with this image where on stretching really, and the easiest way probably is mask stretch. I use that a lot on things like Andromeda, Orion, things like that. It holds the core back, and also it holds some style color. Yeah, and what we're after is trying to keep style color in the images, because this actually has quite a lot of nice colors in this target. So there's a lot of hydrogen alpha. You can see the pinks sitting here, and the idea is to try and retain some of that. So if you use a mask stretch on this, yeah, then it will mask over some of this, and it will stop it overexposing. So we put a little preview box here, go to mask stretch, select the preview box on the image. That's its background reference. You can adjust this value. You can take this up to like 150. I generally stick with this at 0.125. Apply it to the image. It'll come back white because I didn't reset it, but it's fairly quick. I should be able to actually do these in my sleep now.
If you've done it for so long, yeah. To me, it looks like it would take me a few years to get to this level, but then again, I know you've been doing this for quite some time, so
And he does it every day.
yeah,
Maybe a couple of months.
yeah, maybe it'll take a couple months.
6 weeks, like the 6-week workout,
Yeah.
Okay, so we've got this here. It's a little bit dark, but I purposely want it like that at the moment because it's retaining the colours in those stars. So
yeah, if I see
we
that,
can give it a little bit of a kick using the curves. Yeah, so we can put up a live preview. Just give it a bit of a kick. Give it a bit of a contrast. Just pull a little bit more out. Apply that to the image. And now what we need is to actually add some colour to it. So at this point, with it being a one-shot colour, it's quite green. Yeah, you've seen the green cast. I used an IDAS filter on it, so that adds a bit more green to the cast on it. So probably before we add the colour, is just neutralise some of the green in there. So you can use the SENR when I can see it. There we go. And you don't have to hit it at 100% on that. You could bring it in at 60, still retains a little bit of diversity in the middle. There we go. So we've got that back. Now we need another mask because we want to add some colour. And adding the colour, we don't want to add colour to the background. Yeah, we only want to add colour to the stars and the object. So with this mask, open up the histogram and select that particular one. Always reset the histogram, otherwise you add two processes, it holds the one from before. And then the left-hand slider, we're going to slide to the right. Just apply that to that image. So what that's done now is it's darkened down the background, and when we apply it to this one, we actually put the visualizer on, yeah, you'll see that it's allowing the stars through and it's allowing the core of the object through. And that means now we can go to the curves tool, put on the live preview and switch it into saturation mode. And when you switch it into saturation mode, you've got the purple lines where the first four boxes join, raise those up, and you'll start to see the color coming out in the stars and in the target. Okay. Just a little bit more, not a lot more, somewhere about there. So the last thing we really want to do is just bring out some more structural detail in the middle. And probably the easiest way of doing that, remove the mask. It does take a minute to do this process. And that's to use StarNet to create a star mask. So click on the Create Star Mask. Apply it to the image, and then just sit back and wait for a minute until it's done it.
Wow.
Gary, I had a quick question during the processing. What is the maximum exposing time with Lund 50 for solar?
There is no maximum exposure time. It's about keeping the histogram set. So the histogram for the camera, I generally use SharpCap because the histogram is very accurate in it. That's the only reason. But the histogram really wants to be about 50 to 60, yeah, on its linear scale. And if you get it in somewhere around there, you'll always get nice surface shot images.
Okay, so 3 minutes, no problem.
Sorry?
3 minutes.
Yeah, 3 minutes, fine. But really you have to look at the amount of files. I mean, if the camera's really fast, yeah, then there's no point in recording 3 minutes worth of data. So what camera are you using?
178 mm.
Right, the 178 is quite a high resolution camera. So you would actually find 3 minutes on that. The time that you stack it is probably distorting the images. Yeah. Less is more with a camera like that. So you could probably record 500 frames and stack 100. And
Okay.
you get really nice detail because it's a high resolution camera.
Yeah.
Yeah. So the 174, it works very different on its pixel sizing. So on that camera, you would probably want 3,000 frames and stack 1,000 or 500.
Okay.
Yeah, but the 178, I would just be like 500 frames, 1,000 absolute maximum, and keep your stacking number low.
Oh, okay.
150 frames, you get some really nice images. Yeah, that both of those, or all three of those images that I showed for solar earlier were off of the 178 equivalent. They were off of the Player One version.
Nice. We'll try tomorrow.
Yeah, we need some sunshine. There's some nice activity going on at the moment.
Yeah. Thanks, Gary.
That's all right. Just got to wait a couple of minutes for it to do this star mask. Unfortunately, when these images are really big, it takes it a little bit of time to calculate everything. So what's the weather like out your side, Scott?
Sorry, say that again.
What's the weather like out your side?
You know, it's amazingly warm. It's been in the 70s, you know, Fahrenheit, and very nice, you know, for this time of year. Arkansas can be very unpredictable, though. You know, it can be raining, cold, hail, tornadoes, snow, and then warm again. So, you know.
We've had it really warm over here. It's really unseasonal. This October's had some very warm weather. And normally we would be going down to, you know, maybe around 10 degrees, something like that, Celsius.
Right.
You know, dropping into the sort of high 50s, something like that. But it's been up just, you know, just bordering on the 70s for most of the week.
Right. Yeah.
Okay, so we got our start
68
mask.
degrees outside right now, and it's you know, it's 10 o'clock at night. So
Last night it went down to 3. It really plummeted. It went,
Ooh.
you know, it had a real drop off. That's the reason why we keep getting the mist and the fog.
Right.
The temperature changes.
Yeah.
So we've created the star mask. All we need to do is revert back. So we've got the stars in the image. Apply the star mask. Then we're going to invert it. And we'll just run something like a HDR multi-scale, somewhere around 6 or 7, and put the D ring in on. And that's to try and draw out some structural detail in the core. There we go.
Wow. Look at
And
that.
all we now need is a little bit of brightness. So we just run a little LHE on it. So normally run this at about 1.5. Just up at about 80 should do it. Just have a look here. So if I feel that's a little bit harsh, what I might do at this stage is just drop back one and then bring this in a little bit lower. So bring it in at about 7 instead. Sometimes it's a little bit of trial and error. Just depends on, you know, what data's come in, how much you got there. But I always prefer it a little bit softer. You can always sharpen it up later on in something else.
That's beautiful.
This is real simple processing. It's real basic stuff, this. Okay, so we try that again now. Put the LHE on.
That's pretty good. That's pretty good.
Yeah, and then we'll play around with this and see whether we can get this a little bit nicer.
It's easy to go too much, I think.
Yeah, there is a balance there, you know, with all of this. I mean, sometimes it works out that you don't need to do the LHE, you know what I mean? It's really a case of it's down to you. I'm probably going to leave it at that. That looks pretty reasonable. Detail's nice on it.
Very nice. Very nice.
There's no point in overcooking it. So
yeah.
That's that. You can play around and add some more color in and do some other bits to it. It's really down to you as to what you like to do.
Beautiful.
Yeah, I've always been a fan of the accuracy side where you ended up, the image where you ended up, where you stopped, for me would be something to just, that would be the post on social media, M33. You
It's
can
funny.
get.
I mean, it's like the backgrounds in a lot of the images. You're seeing the backgrounds really, really dark. So they've got a really harsh edge from the target into, space.
Yeah.
And, by keeping it soft and keeping it gentle, you make it a nice image, even though it's really very little data. I mean, if we take an hour's worth of data, it's not a lot.
Right. We've got a measurement over here in our little corner in Michigan, a gentleman that minimum 30 hours of data. We've named it after him. We call it a Struble. So if you can spread, if you get 30 hours of data, you've had a Struble, Doug Struble. Scott, you may remember him. Yeah, he's been on the show. He's got he'll take 2 rigs and point it at the same target and go 15 hours each. And then he brings his data. I believe he uses PixInsight as well. If not, he may still be back with Photoshop. He gets an awful lot of data and then he goes in and he plays with it. So
there's no real substitute for data, at the end of the day. But I've always looked at it that, not only weather, you've got other things going on, time limitations with work, all sorts of things. So the average person is only getting a couple of hours a night if they're lucky. And a lot of that time is kicking the equipment, trying to get it working. So if you actually really boil this down, with frustration, they are struggling to get it. So it's really coming up with ideas of how to process that and get the maximum out of it, just for fun. So here to do 30 hours is probably, a couple of weeks, something like that, because of the weather. This time of year, now I'm at the moment for the last week or so, hour and a half an evening, something like that, before the weather will change. So it doesn't matter what is forecast, you just know that that's going to happen here. But sort of 3 miles over the mountain, we've got the massive lakes here, and they hold the water. So if you get this temperature change, you'll just get the mist and the fog start rolling in. And I can watch it. Look down the mountain and look into the valleys there, and you can see it starting to build. And that's it. So 30 hours a day.
Sorry, guys.
That's right. As much as you'd love to do it, it's just not possible.
Right.
That's the thing.
Yeah, it's one of the things I saw being out in that dry area at Okie-Tex is the difference in the sky itself, and we were up 4,000 feet. It's a difference in what you're able to pull down in the same amount of time changes as well. And there's just more data to get in a shorter amount of time, but then you'd have to travel to wherever those, and I don't know, over in the UK, I don't know how far down in Europe you'd have to travel to get to something similar, or if you'd have to just come over to the States in order to be under those skies. And then that gets prohibitive too.
I'm Baltimore 2 to 3 here.
So that's a nice, even though you've got humidity, that's still a nice sky when you can shoot at it.
The humidity is your issue here. And it always will be. But it was like I was looking at your Milky Way shot, and really our cutoff is, or certainly for me here, is about just underneath the Swan. So at the Trifid, anything below the Trifid, really you're not getting.
And see, we can, I've actually got the Bortle 2 Milky Way behind me, and that's our cutoff, the core. And then, over here, we're done. This is when it was rising, and this is about as much as we get in Michigan, where I am. That's our Bortle 2 sky. And when I go out, you can look at Maxi's behind him. He gets all of it. Lucky Maxi over there. Look at it. Look at his Milky Way behind him. He's got both sides of the core going. He's got the whole bulge. So it does depend on location, most of the shots, but like you're demonstrating, a lot of really good astrophotographers, what data you get, you can use tools and really bring it out. And there you go.
And I think that is the thing, the progression in the software has really allowed you to do that. The same a little bit with the equipment as well, but in general, I mean, we used to do the same with the DSLR. You shoot for an hour on whatever you got for an hour. And I always used to have that old adage that if I spent more than an hour on processing, I was bored. So I still really run with that. Yeah. It's like, everybody seems to think that I love processing, that I hate it. It's that's why I find easy ways around it.
Yeah, it looks like a lot. You've got a lot of the scripts there figured out in Pixin Sight, and you've got your process down. So first you want to do this to the image. Here are the steps. Now I want to do this. Here are those steps. And I know it takes a while. Once you get it, you're just going through, and then you're looking at your image to see what you got to take your next steps.
But
So
if you've got 30 hours of data there, you're going to spend a lot longer on it processing it. If you put the effort in, to capturing it, you're going to spend more time processing it. But for this sort of stuff,
that's probably why I'm into wide field astrophotography, or wide field. It's nightscaping. It's however you want to call it. You have something to start with, and then from there, you're tweaking it to make it look more real. Or I've seen surreal stuff done, and I draw the line where it gets to be a little too surreal, and I prefer having accuracy.
Excuse me, getting the Milky Way shots with the meteors coming towards you, and all that sort of stuff. It doesn't do anything for me. It's got a technical ability in Photoshop, but that's about where it stops.
Right.
I think all of it has to have some realism. And I think that's what drives a lot of astrophotographers is, you're capturing what is there or what was there, back in time, in a sense. So that's really what you're trying to represent. And what drives you is probably to improve on that.
Exactly.
The next time you go out is to improve on that, to get a better image than what you did the last time. So
it's a never-ending battle, no matter what level of astro we do. We're trying to show what's out there and what's real, and it's you look at an image and say, okay, here's where I could improve. I remember what I saw with my eyes, and the eyes tend to, they're your best critics. It's like, you saw this, and this. Trying to capture that it's kind of a chase.
But that's no different to putting a phone on the moon, is it? If you put a phone on the moon, to get that exposure correct, to actually resolve any detail on the moon, even though it's going to be small, what the eye sees to what a camera sees is totally different, And I think that's what makes it interesting, and it's trying to pass that fun side over to people. It shouldn't be a chore. It should be that you're having fun doing it and enjoying doing it.
Absolutely. Absolutely. Well, Gary, thank you so much, man. Thank you for coming on.
No problem.
Yep. Up next is Cesar Brollo, and all the way down to Buenos Aires. And we're always happy to have you on, Cesar. Thank you for hanging in there.
It's a pleasure listening to Gary about astrophotography, the conversations with Adrian, the pictures of Adrian of the sky, the processing, the image processing, live image processing of Gary Palmer. It's an honor to be here. Let me change my internet connection. It's something that I think that maybe you cannot listen me good, because I think that, okay, well, now it's working. I don't know how many times. Well, in the last safari, I show a live image of Jupiter with a 5 inches Maxi telescope from my balcony. I processed the image. Let me share the screen. And this is that I could
very nice
make.
Cesar.
Yeah, yes. Do you remember that? I remember that you say I can see the red spot. Not now. Now again. this is the spirit of this kind of image. The processing is choose the better pictures, make something with the wavelets, and was a really very bad seeing night with a lot of turbulence, and a mix of local seeing or local turbulence. I don't know if the word turbulence is okay. It's okay. Turbulence is in Spanish, but I think that turbulence, the mix of air, hot air, and well, but the surprise, turbulent, that this is all that the big part of the problem of the seeing, the movement of the air, with different temperatures, of course. And well, last Saturday, we were preparing the next Saturday star party in Observatorio San Miguel, and we went to the observatory, to work in some and the plan for for receive the people, for where we can put the telescope to show live image. Of course, that we start. I'm carried my telescope, the first light 127 magnetop, and I took a series of pictures of Jupiter and something of the surface of the moon. Look the difference between these pictures and the next. Let me here.
Wow.
With the same telescope.
Wow.
Excellent.
Yes, it was really different because when I had we had a little bad seeing, but only because it was incoming a shed screen current, and when you have this kind of current, you can see something like like a grain of all 16 millimeters filming. When you use maybe high sensation film, and you see the grain moving in the because it's not a it's a very high, a very high altitude turbulence, but we can make something great for this. And for this telescope was a really huge proof that of quality. Here you can see a part of the red spot. Here the 1 to 3 storms. Some people told me that this one are more recently this storm, these points in Jupiter, maybe in the last few years. Here where I think there was Europa and EU. I don't know if you can see, was interesting because first of all, I thought that they had some out of collimation in the telescope, but was not, was the how do you say, was an optics, like an effect of optics, but by the turbulence, exactly to replicate another image of the satellite eyes. Was very interesting because when three different telescopes, refractors, Maxutov, Schmidt-Castle, we say the same. You know, because I know how uncollimate telescope is, and I say, come on, I can see something like a ghost of the EO and a ghost of Europe. But it was great to see that the optics were very, very well. And here is a crop of Jupiter, or I think that it's from another video because the position of this is a little different. Here, the surface of the moon in a quarter crescent, and very nice to shoot.
Spectacular.
This is a very interesting thing to see in this crater. I don't remember the name now, but it's in the first time of the crescent moon. You can see with the shadow of this, and this is very, very interesting. Not all time you can see that. Here, another picture, pretty for a telescope that the name is First Light, that you think in your first telescope.
Yeah.
Really, we had a lot of fun. And really the details comparing. I have pictures that my friend Fernando Ricardini took with his mid 10 inches telescope, AFC is of course that have more resolution, especially in Jupiter, with details that we thought that really was the limit was the diameter, because really we can saw that the difference only in the same times between the same camera type, the same atmospheric conditions, was really the difference between 5 inches and 10 inches. But in the moon was really similar. The details was really great to have a telescope that you can carry in a small, in a small box, and that work in this quality of image. Here, with the conjunction.
Oh, that's beautiful. I love that.
Yeah. Here with the moon, Venus,
yes,
and well, the conjunction of that last Saturday was amazing. With here was Scorpio. Here is the last week in the Global Star Party. In my balcony, my balcony observatory. Here is the Jupiter.
Nice.
My the mess that I have here, because it's time to make my daughter and my wife is planting tomatoes or a lot of things. I confess that all time I kick the pots.
Oh no.
No, because in the darkness, Scott.
Yeah, I know.
Darkness, they say, oh, come on. I kick the pot, I put all in the, well, sometimes I make a disaster because, it's not a big balcony.
Yeah, right.
Yeah.
I can imagine what
your wife is
say in Spanish.
Yes. Of
course, there are some people that are watching this, but I can't pronounce it. But I think what you can, what you say. That's I really, I imagine it.
Yeah. here you have a wide view of the balcony. This
Cool.
was the last week with the position of Jupiter going back in the background of the buildings, and the clouds that every time that I put the telescope in the balcony, of course, that need to appear. Well, this is the thing. This is a picture this last Saturday of the trees and the conjunction. This kind of tree is very nice. The name is Araucaria. It's a great tree. It's from the Patagonia, but you can plant in Buenos Aires and grow and have, maybe these trees have more than 50 years old. It's very interesting, the shape. It's really different.
Yeah.
Here is Fernando Ricardini, that is a member of Bella Vista El Cosmos. That is our group to restoring and preserving the observatory. Here is the building of the Celostato. And of course, that I will prepare a lot of pictures next Saturday to show you in a presentation for our next event. Is the first, the last, one of the last event in the year. This one is for all public. In November, we'll have only for amateur astronomers with their telescopes. Next Saturday, they come. The people can go to his telescope too, but you know, it's a mix between all people, and it's more for the people visiting the installations and know who is the plans to rewild in the equipment. And here, well, is the flyer, one of the flyers. Here we use a laser from the Gustav refractor. And well, this is a part of Mariano Poisson, of course, for solar. That is he's a genius for that. Well, and all different expositions for to talk us about the all things of things about the observatory. November is for amateur astronomers, of course, and Maxi Falieres and anybody that can go to Argentina, no problem. And really, of course, that I need to advise, Maxi knows that is a suburban skies with very light pollution skies, like maybe a little less than Buenos Aires city, but you know, it's to share a time with the people that love astronomy and curious people at this time for this Saturday. In November, maybe we made discussions about astrophotography. If anybody, if somebody of us, Adrian, Gary, Scott, like to appear in a video conference,
sure.
Of course, that for next time.
Yeah, I'll
November,
volunteer. Sure.
You're completely yes. For us, it's a great, because it's especially for amateur astronomers. Maxi, of course, that he needs to come here in November, because he told me that yes, next Saturday his wife, yes, I know that his wife says no, but in November, in November he promised me that he came to Buenos Aires to visit us in the observatory.
Yes, I will be there. You have my word. And we have to see, because the pandemic situation, it doesn't allow us. So now, well, certainly we can be together again.
Of course, yes.
And of course, I will send you chorizo seco from here.
Yes, we are waiting that. Okay.
So Maxi, you're drinking the mate, right?
Yes, it's a company to. Well, I'm here alone right now, but and also when the nights maybe it's cold, but tonight is fine, a little wet, but yes, I prepared the dinner. It's a una tarte. It's a pie from with cheese and jam, jamón.
Okay.
And so I will be eat that more later, but the mate is a drink to have that company when you're talking, and of course if you have friends to in person, you share it.
Sure.
But when you say thank you, that means that you don't want anymore.
Oh, I see. That's it. Thank you.
So
I'll keep
I
that
give
in
you,
mind.
yeah,
No,
if
no,
I give
no,
you the
yes.
mate,
Usually I say thank you. Can I have another?
No.
Yes. No. Yes. For me, Adrian is the same. No sense that you because maybe you think, okay, I am American. I don't know the culture of these crazy people. But the first time they say no, if you say gracias, thank you.
Yeah.
You're saying that you know the idea because it's thank you. I don't know. I don't. Yeah.
Yeah. Sometimes.
Yes,
Yeah,
it's the same.
I'd say we say the same thing.
But
We go,
the crazy
thank you,
idea
like that. You
is
kind of. No, I don't need
why
it. Thank you.
Why do they
Yeah,
give me the mate? Because you say thank you. Why? Come on.
I think it's because
Well-
it's maybe a little offensive to that one who is preparing the mate.
Yeah.
If you say, okay, I don't want anymore. So that's maybe.
Yeah, the body
Shocking.
language would have to help.
Yeah.
Yeah,
you
maybe.
see that changes everything. We're so used to having to say it over the internet, so you fill it in. The body language I would tell, because I would like you say all the time, Cesar, I would say come on and bring some more. Or I would say no thanks and push. You would
For
have
the
to watch
audience
the head.
that doesn't know what mate is, it's kind of a tea, right? Like something.
Yeah.
And it's got a lot of caffeine in it, right?
It sounds
not
a
too
little.
much.
Not too much caffeine. Okay. So you
Yeah,
can drink it all
definitely
day.
something I
No,
will.
not too much. Not too much, Maxi.
No, I didn't put it.
We was talking. Yeah,
I didn't put it.
You notice that Maxi stays up all night,
It's
okay,
talking,
right?
It's
I was
offensive
sure-
if you change the way that you prepare the mate.
Yeah.
Depends from the region. It's offensive to another place from where they prepare. For example, in Brazil, they all prepare the mate, but they prepare it a different way. They put the yerba, the plant, more to a corner, and then they put and then put the water.
No in Brazil only.
In Uruguay, and also I think in Buenos Aires.
In Buenos Aires.
Some neighbor from Europe, but here now.
Well, it sounds to me
Neighbor
like
from
it can
Europe.
be prepared. It can be prepared with some libation as well to kick it up. So I'll have to find out when I finally make it down there to see how the different ways it can be preferred. Looking at the night sky, it
Adrian,
sounds like a delightful time to me.
Are you using a t-shirt from Netherlands, or I'm crazy? No.
No.
No, sorry. It's the same
No,
color and the same.
The shirt is just somebody came up with this from years ago, and yeah, it's orange, but it was an old softball shirt. You have hardball, baseball, and then you have softball with the larger, and it's slow pitch. Back in the those days I played slow pitch softball, and now I just play hardball, even though it's worse. It's harder to do regular baseball, but I enjoy it when I get the chance.
No,
I
excellent.
may
Excellent.
try and play this week, but
We will give you a T-shirt of River Plate, of course.
I look forward to that. I will enjoy. I will wear it often.
Yeah,
yeah.
You remember
Still
the
figuring out
the premise of Maxi. Yeah.
Yeah, still figuring out how I'll get down there, but it's on the list. It will happen.
You just get on an airplane, Adrian, and go.
Yeah, I have to pass that through the wife, and
that's different.
Yeah, and then we have the pandemic to consider. This long trip was a road trip. We didn't actually fly to Okie-Tex. We drove down, took a few days, stayed at a friend's place. He came with us, but it was a good trip. We ended up saw a lot of America's heartland in the process.
That's right.
This is the T-shirt.
That I look forward to that. That's a beautiful shirt.
Sorry. Well,
it's getting lost in the universe.
Yeah.
Yes.
No, but I can see for the most part. Whether or not I can actually play is a different matter. I'll have to continue to work on my weight loss goals, but I'm sure that would I'll take whatever shirts are offered. So
right.
No Boca Juniors. No.
Yeah, if you have 2XL though, that would be nice.
Excellent.
All right.
Okay. All right. So Maxi, it's all yours, man.
Okay. Well, I think I'm the last one, but again, thanks for inviting me, Scott. And hi everyone. Good night. I think sometimes I didn't say hello to some people, but hi, Harold, Locke, Beatrice, and Jeff Weiss. I think.
Oh yeah, Norm Hughes.
Norm Hughes.
Yeah, Josh Kovac is watching right now. Mm-hmm.
They always watch us from what we are doing, and they support us. So thank you so much.
Yeah, they're great. They're great. All these people are, so it's wonderful. We have, let me just kind of go through the list of people that we're watching today. We have Harold Locke, Martin Eastburn, Tarek was watching from the UAE, Jeff Wise, Billy's Astro was watching, Sentil Nagapan was watching. We had, let's see, Gary Albin, who's wanting to go down to Winter Star Party. We before we always knew him as Book Davies. His real name is Steve. He was watching, and let's see who else. A lot of they're all talking to each other. Friend Kaido Jong was watching.
There are too many people tonight.
Yeah. I'm only through half of the list. So there's a lot of people here. Thank you all for watching and participating and asking questions and chatting with each other. That's what it's all about. This is a star party for sure.
Exactly. Well, good night, everyone. Tonight, what I want to show you is some things that I've been doing this couple of days ago. First of all, the last GSP, I was doing a live view with the camera and the equipment outside. And when we were talking, I was doing pictures of 47 Tucanae, and then I process and I get that night. Do you see it?
47 Tucanae is very impressive. I love it when you do that.
That's beautiful.
Yeah, that's a beautiful globular cluster.
I think there was only 20 minutes of taking pictures of 1 minute. You don't need too much because they are all stars. So and also you have to prevent to get very brightening the core because
blow out the core.
Exactly. It will get very white. So well, that was last Tuesday, and the Saturday I have some free days from work. That Saturday I didn't went because I have one day of holiday left. So I want to do some solar pictures and put the equipment outside very early. It was maybe 12 p.m., 1 p.m. And well, I grab it, it's very at the midday. And I was doing, well, here's the notebook covered with a box of carton.
That's mission control right there, Maxi. Mission control.
Exactly. And I was, because I can't see anything for the shining sun, I was doing the working with AnyDesk, controlling inside here in my home,
sure.
and taking some videos. And well, we have in these days some kind of solar activity, and we have the dark the sunspot, the 2882 is the principal, and now it's going to the border of the sun. But this is what I get that midday with this scope, and of course a solar filter, a better solar filter.
Mm-hmm.
And here's
nice.
the principal dark spot, and also a couple more very near. Also, this region has some kind of dark spot, but I love when I see at the edge of the sun these whites or more brightening places. It looks like some lava. Of course, this is plasma, but I don't know. It's like it's getting covered out. I don't know. It's like a broken egg, something like that. And I don't know why I love to see that. This
right, yeah.
These places.
Sure.
And in this case, they are in a very places of the sun. So that day, well, my wife say, "Oh, you are going to with the telescope." We went to have a lunch outside in a place called Choripazo. It's a place where you go if you're traveling. You stop and eat some choripan or some sandwich with meat or something like that. And well, then we went to, because I want to teach her how to drive the car, and we went to a farm town called Ramon Diaus. That's how it calls. And we spent taking mates that evening. And well, this is my car. This is a very farm area. This is an abandoned station, but maybe, I don't know, 40 or 50 years ago, the train passing by from here, but right now it doesn't. But this town is very quiet, very calm, and they have this amazing view of the sky in the middle of the town. And well, the streets are from like this. No, it doesn't exist, the asphalt, the gravel, the pavement, exactly. And but I like how it looks like, because they have, of course, some old structures from very old, 100 years of construction, but also new houses, and that gives very colored place and quiet. I remember I saw a Firestone place. They have the fuel pumps. Pumps. I don't know how to where you put your fuel.
Yes, fuel pumps.
Exactly, and they are very oxidated, but very old. They still have Firestone put in there because it was a place to change the wheels. And then near of there is this river that calls Salty River or Río Salado. It's a very quiet place where people go to fishing, and also you can see this view. In this case, it was at the afternoon, and the sun was downing. And I told her I need to take pictures of that because I want to do some nature pictures. In this place you can see a bird. It was like in there, yeah. and also well, the fishes was, I don't know the word jumping, but the river is getting dry. It's maybe the season, but it was very low from another time that I went there. And this is another picture. Maybe Adrian, do you like it?
Yeah, no, it's a great picture. The only, if that's not a bird that's flying towards it, then, and that might be a bird there.
Yes,
but
it's a bird. It's a bird.
Yeah, there it is. There's the wings.
The big bird.
Yeah,
yes.
It's a beautiful picture that you got the sun. Of course, your camera, you see it a lot brighter like that. You typically see it a little brighter. Your camera, you had a lot of birds flying around too. But
yes, they were eating.
And you do have some of the censored dust, but that happens.
I tried to clean it up, but I couldn't.
Yeah.
So well, then I remember see this sunset, and the moon was I think you call waxing, right? A waxing moon.
When it's growing, the growing waxing moon follows the sun into the ground. Yeah.
And also you can see Venus, and behind of that it was Jupiter. It was like this sky. It was a very huge perspective. So when I get home, I have my equipment outside, and I say, okay, I had to, of course, take pictures to her, to the moon. So I only did 20 pictures with a single picture with the camera with the CWO. And when I started, I did some Drizzly 1.5. My computer was very in the point to explode, but you can see too many places. I love when the craters comes up. I don't like see the moon when it's full. I really don't enjoy it because you have too many irregular places and craters, and well, it's you can see maybe 100 kilometers or maybe more, and it's like a little circle, but it's a huge place and also deep, for example.
It's huge.
So, well, when the moon starting to go out, I started to well, I was yelling to my neighborhood because they started to start the fire for a barbecue, and I was really upset.
They gotta block that. The barbecue itself is fine, but the light from the fire, not good.
The smoke is also
even worse. Yeah,
exactly. And also another neighborhood turns up his backyard LEDs, and well, it was like morning. But well, I was trying to do some pictures of the Dumble Nebula. This is only DBE. I think Gary is here. He knows what it is, and this is what I get when I get stretched. And
M27.
M27, exact. The Dumble Nebula.
Great picture.
Nice.
I didn't process this.
Thanks,
I think I did maybe 1.5 hour, maybe stacking, doing pictures of 3 minutes, but I didn't process this yet. I only put up the dynamic background extraction and well, I had to still working on. And well, when I realized that it was getting low because I had it to the north, passing by the meridian to the northwest, and then starting to go very low. So I had to say, okay, that's it. I can't take any more pictures from there. And also I was more later starting to upset for the clouds, because I remember was inside watching a movie with my girlfriend, and you know, I heard that alarm constantly, and I thought that it was in the movie, but she said no, it isn't the movie. And it was the clouds covering the
cloud alarm.
Exactly, from the PhD software. And oh no, I had to stop that. No, I don't know how. No, it was awful. So I wait more later, and I remember to talk with Cesar, to chat with him. And it was Saturday night. We have nothing to do.
What's 4 a.m. on a Saturday night? Right?
When I returned from San Miguel Observatory, only at 30 past 12, and say, okay, it's great to go to sleep, or maybe I can start to process Jupiter, the pictures that and another pictures with the pixel with the not big inside with the Registacks or Autostack or whatever. And I say, okay, hi Maxi, how are you? And we started to talk.
and also you know, I was processing and seeing what I was capturing that time, and I need some kind of company, and of course, well, Cesar is up, so let's talk with him.
Yeah.
So well, I went to M42. I just today I finally get the processing image, but I really don't like it too much. But I have to be working on. This is the picture that I took of M42. This is what I have processed.
Wow.
And
nice.
You know, I think I will have with the stars some reflection, but no, you know, it's a good thing, I guess. And also,
spiders.
Exactly, and I thought that maybe, well, I was practicing with M42 again because I don't want to burn the core, but I think it's a little bit, but the structure surrounded it's allowed to see it. But like I said, the night, it wasn't a great night. I remember I have well, here in Chivigoy we have still mercury lights. It was very orange, and I have only at the zenith some kind of dark circle, small, and everything was very orange and white from the LED lights, and no, it was awful. And well, then when I tried to do some things because I want to see how works the camera and the field of view, I went to M78, I think it calls. It's also in the Orion Nebula. But you know, the light pollution and I think the clouds also, or something clouds, they bother me.
But look how
But
much dark nebulosity. It looks like two eyes are sticking out of the out of a cave or something.
exactly. But I really like this place.
Yeah, it's beautiful.
This place from here, because they have stars, but it's like when you see the moon through the clouds or something like that. When you see that kind of light, you know, you know there is something behind it.
Yes. Something mysterious. Yes.
Exactly. And also these places here that have a reflection from the stars, but also the dark nebulosity is amazing. So days before of this, I tried. Well, I put my equipment outside. It was a clean night, everything. But when the place that I want to take start to comes up, the clouds say me, put your grab inside again and go to sleep. So I was really upset because I want to capture the 67P comet, the Chumos, I don't remember the Russian name of that comet, but because it was passing by very near from the M1, the Crab Nebula, and I want to do some 2 pictures of that place that night, and no, the clouds doesn't allow me. So this Saturday night, I was able to capture it. I only did 23 minutes of 1 minute pictures, and you can see here is the 67 comet.
Oh yeah.
And also it has a little tail. I'm still practicing of stacking from a place the comet, and in another image the stars, and then putting it together. But sometimes the background goes very weird. Here's, for example, the stars, the brightening stars have a little shadow from the down, but that's why because from the stacking comet only well, I don't know how to say it, grabs that light of the stars. So, well, I want to show you this kind of well, a blink. Well, it's like a recording. This is all the frames that I took that night, and this is an animation to see how very fast how moves this comet is very fast. You know, I can put the
motion of the
the
comet.
motion, and
nice.
You can see how it moves.
Yeah.
This is only 23 minutes. And when you stack this, when you stack all the stars in the way of always, it's the comets will be in all this place stacked. So
nice.
This was maybe I think it was 3 a.m. Yes, it's still very down because for the light pollution, and also the night was awful, but allows me to still taking pictures and still practicing. So well, I think that's all. Yes, I show you. Yes, that's what I was been doing. This Saturday, Santiago Mayese, a friend from Cesar, invites me to the star party that they will do in Bella Vista, but my professor of physics here asked me a month ago if I was able to do some views of the moon, because it will be the international moon view or something like that. So he wants to he invites me to be there, but I can be in both places. So the next month I will be with Cesar, and that's why I think I will bring my equipment. So let's see what happens. So thank you, everybody, and well, let's continue.
Thank you.
To the after party.
Yes. Okay. So we will take a short break, guys, and be back in a few more minutes, and we'll convene on the after party here. Okay.
That's excellent.
Good. So unfortunately, it's about midnight here. So hopefully, folks join you all for the after party. I am going to head up and grab some sleep after my long trip. This has been very enjoyable. It's good seeing you all again.
It's good to see you
Cesar,
again.
thanks.
Thank you, Adrian.
Yep, I uploaded some of the data I found. So there's so many other pictures I'm going to find that I took from the Okie-Tex Star Party. So you saw one of the other close-ups I didn't even know I had. And so there's I also have images to start stacking. So there's going to be some work on the computer to see what I got here, but that's coming up.
You have too much to work on.
It's all good to have too much.
Yes.
Here in the States, we say a lot, and when we say too much, then it's more than we can handle. But no, it's too much is a good thing. I even got data. Another person handed me a USB stick with even more data to see what I could come up with. Maybe I should send it to Gary or one of you, Maxi, and say, here, use PixInsight on it and see what you can come up with. He had some wide field views, some nice, sharp wide field view data, and wanted to see what I could do. So I'll play around with it as well. But I'm going to take off. My camera finally working. The one that I want to use with my setup on the computer is finally working. So hopefully it can keep going. It's the camera that can zoom in and out, so I can get a good closer up picture of myself with this. So hopefully that will continue, and then I can use this instead of the little wide, small cam that doesn't work or don't like it anyway. But yep, I see Jeff and a few other people, I think Tarek. Thank you all for the comments. I see it. And I will go ahead and head out. So
you have to rest.
Yeah, I'll see you two gentlemen in the near future.
Okay, man.
All right, take care.
We'll be in touch.
Yeah.
Good night, Adrian.
So I think it's only you and me, Cesar. Well, I don't know.
Yeah.
So start talking in Spanish. Do you want?
Poor people. If you start to talk in Spanish, in our Spanish, that is with the slang, people say no, this is impossible.
We talk too much. We talk very fast, and our Spanish is not Spanish.
No, Tarek.
No problem.
We promise talking only in English.
or I will add Arabic. Well, we have some kinds of little words in Arabic, I think.
Shotam Gens, Harold, you're a genius.
Well,
yes, we finished the last time to 4 a.m. But I promised tonight to go to sleep in 15 minutes.
The 2
by the
a.m. is
healthy of Scott,
the
you and me. Yeah.
No,
No, it's amazing your picture of the comet, Maxi. Yeah. For me, it was amazing that I accompanied you in the
virtual mode.
Yes, and you too to me, because the process of Jupiter was great. In the morning, I say, okay, I try to put in sequator, not sequator, sorry, autostacker. I put 1.5 Drizzler. That is okay, and I prepare because yes, my computer can explode too, and I couldn't see some difference. I don't know why I made two kinds of different process. One only with the video point .avi pointing only in the pixels. I know in the Registax program. We say a joke with friends that are astronomers, amateur astronomers like us, that will say, "Oh, do you use Registax?" Yes, I have my diskette from 1996. I made a joke that because the joke is that never was maybe the last edition of Registax is from 3 or 4 years. I think this from 2016, and but it's still working very well because I put the video of the Jupiter. Great to say I only move the wavelets a little. Say, come on, and I of course that I used a mix of your consejos,
advices,
your
tips.
advices, and the advices of Fernando Ricardini, a mix, because the problem is that we are using the big size pixel.
Galaxies once were regarded as island universes, isolated realms of gas, dust, and billions of stars that were separated by distances unimaginably vast.
But no galaxy is an island. In fact, galaxies prefer company. The gravitational pull of a large, massive galaxy attracts like-sized and smaller neighbors. Galaxies may gather in modest groupings like these, or congregate by the hundreds in enormous clusters.
This is Abell 1689, one of the largest galaxy clusters known. This view spans some 2 million light years, or about the distance between our Milky Way galaxy and the nearest big spiral. Into this space, Abell 1689 packs more than 500 galaxies. As astronomers mapped nearby galaxy clusters, a more complete picture of cosmic structure emerged. Galaxy clusters gather in superclusters, and overlapping superclusters form chains and filaments spanning huge swaths of the sky. Welcome to the cosmic web. This all-sky map shows structures created by more than 1 million nearby galaxies.
Deeper studies show that this pattern continues to even greater distances. The cosmic web appears to be the backbone of our universe. The The universe came into being 13.7 billion years ago. About 400,000 years later, it had cooled enough to form the first atoms. The event created a sudden pulse of light that astronomers now measure as the cosmic microwave background.
But then, the universe went dark. For millions of years.
Eventually, hydrogen gas cooled enough to collapse and form the first stars. These stars not only re-illuminated the universe, they became the seeds of all future cosmic structure.
The James Webb Space Telescope may be able to see clusters of these first stars. It may even catch a few of them dying in supernova explosions.
Either the first stars or their progeny gathered into the first galaxies. These were small, gas-rich dwarfs, nothing as grand as the big galaxies we see today, but they were the building blocks of modern galaxies.
As the dwarf galaxies form, collide, and merge into bigger galaxies, the cosmic web begins to take shape. With the James Webb Space Telescope, astronomers will glimpse the earliest phases of construction that led to the universe we know.
Well, is it just you and me, Maxi?
No, I think Cesar is here too. Hey, ¿qué hace, guacho?
There he is. Yeah. Yep. So
we are thinking. No, sorry. We was talking what kind of time to talk in the after party.
Yes.
Well, tomorrow will be lunch. I think it's the Blue Origin rocket.
Yes, the origin, Blue Origin. Yes, Maxi. Yes.
It will be tomorrow, right?
Yes, with
Or
William
today.
Shatner.
And
Yes,
who's
today.
flying on Blue Origin this time?
The Blue Origin. Yes. I
It's
saw
William Shatner, right? He's flying.
William Shatner. Yes, it's amazing.
Captain Tiberius Kirk.
Yes, yes. Maybe you watched it's a fake, but it's so amazing that somebody turned the colors and the design of the jackets of the member of the crew, the crew members, to the Enterprise jackets with the colors of the Captain Kirk.
I say
it was amazing. For me was you.
Nice.
I am so nerd.
I think well, it will be traveling with the insane. Well, I don't know. Well, the placket of the inside of Enterprise. The pin. I think it will be launched with that. So
yeah,
for the fans, it's something epic.
It's something epic. Yeah. Yes, I think that is something historic because of course that is the time, the age of the civil flight to the space. I saw in the Netflix the last documentary of I think that is Shoot Down, maybe the name of the documentary. Cuenta regresiva is in Spanish, but I think that sometime I turn my Netflix to English or Spanish. I don't remember the name of the titles of the series or the movies, I think that is Shoot Down. Counting down, yes. It's the history of this four crews is amazing. It's very the history of the girl that is actually she's medic and she's doctor in the same hospital that saved her life. It was very inspiring history, and think that these four guys, they went to the space and they lived 3 days in the orbiting the Earth. It's a magic.
I think
really the people
today
need to see this documentary because it's incredible. I couldn't saw this. Sorry, sorry, Maxi. I couldn't saw this. I know because you had before the launch, you have to watch in Netflix this documentary to know the people. For me, I thought, no, I cannot watch this only because if I start to know the people that is going to the space, is something going wrong, because I watched the Challenger and the in live TV, and for me was something Scott, that was for our generation was something like terrible, because we hadn't expect of the idea of the time of the shuttle, the shuttles that. And for me, it was impossible to start to watch this program and say, okay, I can see that only if they return safely, and I need to watch the show, because if not, it's impossible to me, because I have an idea of the people going to the space, and something is wrong, because my fear was remembering the challenge.
Oh, yeah.
Challenger
So
and the Columbia.
And the Columbia,
For
yes.
me, yes.
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 Yeah, that's right. And I remember too, Apollo 1, when they were.
Wow. Yeah.
So the job that they're doing is dangerous, and it's also dangerous for tourists,
Today.
but
sure,
also diving very deep in the ocean's dangerous, and skiing tall mountains dangerous, and getting on your freeway and driving to your work is dangerous.
Yeah, absolutely.
Living in Argentina.
Everybody's like, okay, there was an accident. There's a
It's
fatality. It's like a no big deal, But if they go on a spacecraft, okay, and there's a fatality, somehow it's worse. I don't know why.
Yeah.
But there's a lot of, I think part of it is there's a lot of hope, and we project our feeling of their adventure, it goes with it, and we know it's dangerous, for every minute until they're back down and the mission is over, right? So it was really interesting. When I was able to spend time with Buzz Aldrin, and we were talking about his mission on Apollo 11, I told him, I said, I had read that you guys only had a 50-50 chance of making it back. He says, they weren't giving us, he said, that's what they told the public. He said, really what it was is they had a much smaller chance of success. Okay.
Oh.
Much smaller chance than 50-50.
Oh, yeah.
And I said, did you think that you weren't coming back? And he said, no. He said, I knew I was coming back, so.
And that's why they still going, and because your mind maybe will change if you start to think about it. But it's like you say, it's very risky.
It's pretty risky. Oh yeah.
absolutely.
Yeah, but you know, we live. Being alive is
No,
risky.
yeah.
Being alive is risky. You know, so
Yeah.
yeah.
Yes.
So you know, a lot of you know, I've been asked. I've asked myself many times, would I go if I had the chance? Yeah, I would go. I would go. You know,
Yeah.
I would love to see the Earth from space. You know, like that. So
Yes. I choose yes. I go. Absolutely.
Well,
One
I
of
think
things.
the tickets cost $100 million.
Okay. Okay. We need Sol telescope. No problem.
Okay.
So here's Harold Locke. He says, as a truck driver, I had to avoid and think fast to avoid being killed at least once or twice a week. If it wasn't for a constant focus, LA traffic is insane.
Or yes.
That's true. It is. Or Buenos Aires or London or, you know,
Wow.
everywhere.
Roads in Argentina. Yes.
Yeah.
It's, something that you tell about the diving, it's something that all people say, okay, diving is safe, but it's first of all, it's something that you went to another space that is water, and
another
in
planet, for example.
1 minute, yes, you feel like another planet. For me, I remember that I dived at 20 meters at night, for example, in a Denver lake in San Luis here in Argentina. Or you say, come on, without, I remember that I start to dive when the life jacket that that actually we use and we can change your level without swimming. We use that. We start to diving in the end of the 80s without suit, because the suit was started in the first time of the 90s. And I remember today they say, come on, I was crazy, because I have only my compensation with the counterweights in my belt.
Yeah.
No jacket. No, my kids say.
So you didn't have
really,
the inflation
yes, I start to dive. And you calculate, you remember that, and when you went down, maybe you was more able to go more down, because your skin suit is we're going with low pressure. Diving suit, sorry. Yes. Come on. And we started with that. And when this little thing comparing with the people that go to the space, especially when the walking, have a saying spacewalking. The name when the
they are. They're a spacecraft when they're out there, right?
Yes.
And it's the opposite. In the water, you have pressure. When you go more down, you start to feel it. But in space, you don't have pressure.
You
have your
kind of pressure.
You can explode because absolutely, yes.
Yeah.
No,
you know, I once I was at a science show, and they had the trainer for astronauts. He was from Russia. He was a former cosmonaut, I guess, and his job was to train astronauts on what to do if they are hit by the small pieces of
junk, space junk.
Junk in space, like like the bolts and he said there's a lot of this stuff out there. It's flying at unbelievable speeds, faster than a bullet. Okay.
Oh.
And he said I said, so what do you do if you get hit by this? He said, if you can, he says, you have about 2 seconds. Okay. And what you're supposed to do is take your thumbs, because it's probably going to pass right through you. Okay. And you jam one thumb into one opening and jam the other thumb into there. And then the vacuum of space will seal around your thumb. Skin around your thumb, so you don't bleed out. Okay. And then they need to get you back into the spacecraft.
That's insane.
It's so easy. Yeah. No. It's incredible. Come on.
Yeah.
When you think in, yeah, and these people think that it's possible and it's real, and it's
I
incredible.
remember saw a documentary that where I think NASA was practicing with the space suits in a huge vacuum chamber, and it was recording that the person that was doing the practicing has the suit. I don't remember what happens, that he start to go sleeping and gets to the ground because it has a little infiltration that the air was passing go out, and his blood it starts boiling.
Yeah,
it's the worst. The worst part is that,
and I
the
think
blood starts boiling.
They realized that how much maybe you feel if you don't have atmosphere or a thin atmosphere that we have here. But now it's very I think it would be horrible to feel that.
Yeah,
it's something like the bends. They call it the bends, and this is what divers get. My father was a hard. You wore the hard hat, deep sea diving. Okay, and
with a helmet of bronze.
Yeah, he experienced people that they came up too fast. Okay, and then they had to be put into the chamber to survive. And he said some people they could never equalize them. They could live in the chamber, but that's the only place they could live. Okay.
Yes, absolutely.
Yeah. So they could never be brought back all the way to normal.
Yeah. And only people that only can walk in the chamber, vacuum chamber, or it's not vacuum chamber. So how do you say to the chamber in English?
Yeah, it's a pressure chamber is what it
is. Pressure chamber. Yes.
Yeah.
I was in one. To
really?
to learn. Yes, only to learn. But I suspect that they had a small blend in the shoulder.
It's called a hyperbaric
chamber. Yeah. Cámara hiperbárica. Yes. Yes, for me was very interesting. The first in my first learning to dive at this time in the 80s. I remember that we went to the inside the hyperbaric chamber, and we inflate a balloon only little, and we watched how the balloon start to
like shrink or expand?
First of all, we inflate completely, and we start to watch how the balloon going smaller and smaller, or something like without pressure. Yes, maybe we went 1 hour, I remember. And the things of the blends are so real that I suspect that I had one, because in Brazil I lose my counterweight belt. And I go to the surface very fast and say, come on. It was impossible to me to stop to go to the first of all, I return to the 6 meter. I make we call it paradas de descompresión. I think that is maybe anti-pressure parades or stops. I don't know the name in English of that. To resolve something of this 6 meter, 3 meters, and go outside. But in in 2 times later, in different times that I took a fly, you know, I felt pain in this area. Because when I talk with people, with divers or doctors that know about divers, say maybe you had a little bend because it's really normal that you have something, and maybe you lost with the time that, because yes, in 2 years more, I never felt in a fly some pain. But the bubbles in the blood are really dangerous. Yes, yeah. But many people say the same because it's are small bubbles inside the muscles, inside the articulation, and this is why, for example, for older divers in the past, they can't walk. Only they can walk diving with the, you know, with the same kind of dive suits, like the helmet. I don't know, the dive helmet is the name, Scott, or
yeah, helmet.
That dive helmet.
In Mar del Plata, in the museum of the Navy from here, from Argentina, they have, of course, too much of
the diving,
diving string or diving helmet.
Hanging with chains, that diving helmet, and you can put it inside and you feel that, you know.
I don't know how many pounds it is.
No, it's
really
very heavy. It's very, really heavy. And you see only this circle and the other side, and I don't know how to work. And for example, in Argentina, the waters, they are not very clean because we have some mix from the river and have very brown waters.
Yeah.
So
yeah,
I don't know how they touch what they have to touch, and that's it. Maybe it's a rock, maybe it's a fish. I don't know, but they couldn't see anything.
Yeah. So during one exercise on a ship, you know, the Navy guys with these diving suits, they practiced a lot on different things, and one of them was salvaging an old ship. Okay, that was had a lot of mud inside. Okay, so they had to have these big hoses that they were putting inside the ship to vacuum out the mud, and then what they do once they have all the mud out, then they flow air inside the ship, and then it raises up. Okay, that's how they do ship recoveries. Anyways, he's down there sucking the mud out, and the hose breaks, and what comes flying out is all this mud, and he's buried alive. Okay, buried alive in his suit. He's got the air still coming down to him. They can still talk to him, but he could not move, and there's no light. Okay, so it's like complete darkness. He had to stay down there because he had to stay down there for like 5 hours because they had emergency vehicles that were a couple, you know, they were like a couple of hours or whatever out from base, and they had to get the equipment and everything to come back out and dig him out and everything, which they did. They got him out. But once he got back on the ship, they said, okay, put on your suit, go back down again right away.
Wow.
Oh,
no,
because he said that's to help the psychological effect of being buried alive like that, you know.
Incredible. No.
Immediately again, yeah.
I believe you that it's great. It is training so hard. That is,
yeah.
But because these guys, for example, here, as Maxi says, here in our river, Rio de la Plata, yes, once a time I tried in the Delta with friends to make to make a diving only to try, and was absolutely black. The
Look at that.
underwater. Yeah.
Warm
This is like
Marina 810.
Marina right 10.
Marina,
Yeah.
And
In the
you know,
museum.
this is in the
Very
Museum of
nice.
the Navy in Mar del Plata.
Yeah, excellent.
Holidays.
But this is something that we are talking about the two different space, no, water and vacuum and space, real space. It's incredible. We have in changing
the subject.
The subject of that we are talking. For me, it's incredible because from last Saturday to next Saturday, that we will have an astronomical event for us. It's incredible because we have something like a fire in the 1 month ago. We are making next Saturday. This is a party in November. I don't know which one of the weekend the third party for amateur astronomers, and the last one I think that it's December 12th. That is the last third party of the year in Observatorio San Miguel. And I'll go to San Juan Observatory Casleo to make an star party with Eric Gonzalez with the San Juan government. This will be maybe in the end of February. Our main star party, San Rafael star party in 1, 2, 3, and maybe 4 of April in 2000. Well, next year, of course.
Okay, I have.
This is the yes.
Give me the
Maxi.
date because in finally of February maybe I will have the holiday. I don't know yet, and I don't know where if we go in holidays, but maybe we go to San Luis from the apartment of my parents, and we are maybe, I don't know, 300 kilometers, maybe a little more, but we'll be in a very good sky, so maybe I can
of course
save that 1 week for that, and then maybe for April. I don't know. I have to talk in
April.
work.
Yeah, April is the main star party because it's our, I don't know how many star parties in San Rafael we made with Jaime Garcia, but it's maybe from 2004. I made the star parties from 1996. Yes.
It's a couple of years.
Yeah. Yes. Yes. I think that the first one was 1996 was the second one, and we made and this year in that year we made a winter and summer edition, and we started to make a lot of different parties. But in 2004, we changed from Buenos Aires, farm area, only 100 kilometers, 60 miles from the city. We changed to San Rafael with Jaime Garcia because we had a Milky Way over our heads and big hotels for the people, and make the star party inside the hotel very dark was our best solution to have a safe place, nice to have your room. You have your room. You have your
Facilities.
equipment.
Yeah.
Yes, actually, we can get you can get your telescope outside because we are using the beautiful terrace.
Yeah.
That is excellent to put the telescope and don't touch in the 3 days that
Do you have electric
you
power?
have. Yes, because we have absolutely all, and you can go to your room only 20 meters. Very, very nice.
That's nice.
Place. And yes, we choose the first of all, we start to think, first of all, we can turn off the lights of the entire area. For example, the 1 kilometers where of the road that coming from the main road to the hotel, they had electric LEDs illumination. We can turn that. We can turn the entire system of the light, of course, only for the illumination.
You can make it really dark.
Really, really. The only thing that you can see is the city at maybe 50 kilometers of San Rafael, but it's not a big city, it's normal.
Right.
And
you see like a small dome.
Yeah.
I see.
And as you have maybe 25% of humid in the air, it's like Arizona. You don't have problem, and maybe you have the city, but you don't have dust or humidity in the air. Really.
So the dome is not very big, and
absolutely, yes, and it's a mix between maybe we can go more to the mountains and have a more darker skies, but something like this that you put the telescope, and if you like, you can left the telescope outside, you can put the cover, it's really, we start to say, okay, the people need something that more comfortable
Sure.
to have astronomy.
That's right.
And they say it's okay because I remember in another parties, the people go more outside, and we need a lot of cables to bring them
even to really dark.
electricity. And the people say no, but I'm not sure. And yes, I'm carrying again the telescope at the end of the night. Now it's funny because we can use the telescope. I say, okay, you can get the telescope here, no problem. It's safe. It's really safe. You don't have any problem. And we can go to the barbecue, eat chorizos or blah blah blah. So all that and you can go to sleep without the only turn off your computer. Maybe your computer you can get to the room, of course, but the telescope with the cover, say okay, or the mount if you feel a little scary, but this was some years ago the change of the comfortability to make astronomy in a third party. I saw in the United States that the people don't disassemble the telescope in the 3 or 4 nights that they
right.
No, it is real. In the third parties in the United States, the people say put the telescope, and only when they go disassembling, yes, it's the best way. It's the best way.
You're right. That's right.
Yeah.
And the comfort, but having a more comfortable star party, have facilities, bathrooms, something to eat, someplace to go to sleep, these kinds of things are very, it's nice. And you may not be in the super dark area, but it's the facility you're describing sounds excellent. So
Yeah,
comfortable.
Yes.
Yeah,
Right.
our first sense was, come on, the people need to feel very comfortable about use their telescope and make photography, and when they need to go to sleep, only put a covering. In exist an excellent in Argentina, maybe the best cover to put a telescope is the same cover that you do use for motorcycles. Are the best way. If you, of course, that if you have the security that you can get a storm in the night, because you for us, like organizers say, okay, we don't have any advice of a storm or very strong winds in the night, of course. Sometimes if we are thinking about strong winds, we can talk with the people, say, okay, carry your telescope, the optical tube assembly to their rooms, or put in the lobby. Normally the people put in the lobby of the hotel, no problem.
Yeah.
And when you can go in the morning, you can put outside again. Or if you like, you can left the complete telescope. Computers too, if you have something to cover that.
Oh, it's safe. It's safe out there.
And yes, it's because the place is safe for.
That's good. That's great.
Yes. Yeah.
I want to go.
I'm thinking that I can wait. Yes, Scott.
I want to go.
Sure. You are invited.
Yeah.
I think that Maxi.
I really want to go too. I really want to go too.
All right, gentlemen. Well, it is midnight. It's 1 minute.
Yes, it's the best safari in Argentina.
Yeah, and I know it's very late.
Okay, Scott.
In Argentina. Thank you, guys.
Here too.
We'll see you next Tuesday.
Thank you
okay.
so much.
All right, and good night to the audience.
Good night to the audience.
Good night. Good night. Good night.
Okay, guys. Good night. See you next week.
Take care.